you very much for taking the time to join us for this workshop on a very important subject, one that's under discussed, shall we say. So it's really nice in the context of the ERIC Forum project and the ERIC Forum to be able to bring the various domains together to discuss a very important subject of quality, reproducibility, and the future usability of research. I'm going to hand over first to Anne-Charlotte Farvel, my colleague at EATRIS, and is also the head of European Affairs and a leading light in the ERIC Forum Secretariat and project, who's going to tell us some of the housekeeping rules this afternoon and also give us a good introduction to the ERIC Forum project itself. And then we'll have a look at the agenda. Go ahead, Anne-Charlotte. Thank you.
Thank you, Anton. Hello, everyone, and welcome to the workshop. Very happy to have you with us for discussing this important topic. I just wanted to say a few housekeeping items before we make a start. So we just now started the recording of the session. So by remaining in the meeting, you're consenting to it being recorded. So please make sure you stay on mute and turn off your video if you don't want to appear in the recording. We also kindly ask you to disable your camera during the presentation. We'll invite each speaker to turn on their camera when it's time for the presentation. And as a notice for all speakers, when there's only 1 minute left to your scheduled time, Anton will turn on his video as a notice to you. And please mute your microphone at all times if you're not a speaker. And we welcome you to use the chat box for questions and comments. We'll take questions throughout the afternoon. If we have time, we'll address a few of those after each presentation. Otherwise, those will be kept for the panel discussion at the end of the day. So before we have the first speaker start, we wanted to give you a bit of background information. First on the ERIC Forum in EATRIS, and also what we want to discuss with you over the next 2 days. So first, because we understand that we have a very diverse audience today and tomorrow, founders, policymakers, researchers, early career scientists from all disciplines, and we thought it would be important to clarify as a start what we mean by research infrastructures, because EATRIS is one, but also many of our other colleagues and of course all the members of the ERIC Forum. So a research infrastructure is a group of facilities that provide resources and services for research communities to conduct research and foster innovation. So research infrastructures are really there to facilitate research for users, for academia, but also some cases industry. And there's actually quite a diversity of types of infrastructures. They can be single-sided, but also distributed, so relying on existing facilities across Europe, but they can also be virtual. And in terms of the services and resources they give access to, here again, we have quite a bit of diversity. They can provide access to scientific equipment, of course, but also collections, archives, scientific data, or computing system or communication networks, for example. So what do we mean by ERIC? So actually ERIC stands for European Research Infrastructure Consortium, and it's the specific legal form that facilitates the establishment and operation of research infrastructures with European interest. So the common points, as you must have understood by now, of the ERIC Forum is that it regroups European research infrastructures that all share this ERIC legal status. So the ERIC community is actually quite a recent community. It's currently composed of 21 established ERICs. The first one was established in 2011. It was Share ERIC, which is based in Germany. EATRIS was established, for example, in 2013. And the latest ERIC established was 2019, and it's Eurobioimaging ERIC. But it's also quite a growing community, hence the existence of this forum, because currently we have 11 ERICs in preparation in all different kind of scientific disciplines. So hence the need for this forum. The ERIC landscape currently covers many disciplines. We have ERICs in energy or environment sector, but also the health and food domain, physical sciences, and social and cultural innovation. And you'll see on the right where each ERIC belongs. And actually today and tomorrow, we're lucky to welcome speakers from 4 of those 5 clusters. So it will be energy, health and food, physical sciences, and social and cultural innovation. In terms of the ERIC Forum objectives, so the ERIC Forum actually is currently receiving Horizon 2020 funding, and this is this funding opportunity that also allowed us to organize this workshop as part of the project. And the aim of this community, of this project, and also beyond the funding lifetime, is to really develop and share best practices among the ERICs, also support the future ERICs in the setting up of their operations. And more importantly, it's also our objective is also to address critical challenges such as quality and reproducibility that we will be covering today and tomorrow. Anton, I'll leave the floor to you.
Thank you, Anne-Charlotte. I've just requested.
Labdien! Jā, jums zvana Baiba Valde.
Hello? Oh, you got into mute. Okay, no problem. It was an accident. Yeah, I'm trying to control the slides. One moment. Can I make that happen? So for today's session, I'll try and be quick so we can get into the talks already. Let's avoid having a discussion about defining reproducibility, because let's be practical and let's enjoy the next couple of days on really hearing about what it is we can do to improve the quality management processes in all aspects of the funding of the research execution process, in order to ensure that we have robust results that we can rely on, whose results we can rely on as being some form of ground truth, whether they're negative or positive. So we pilfered from the scoping document. That's very interesting background reading. The scoping document created by the European Commission on quality and reproducibility. 2 terms that are interesting for us today are reproducibility, so whether you can actually completely copy the protocols and the study to see if you come to the same conclusion, and replicability, where are you able to reach the same conclusion, but perhaps by another means. I think that's so very important, but I would like us to be focused on what the main goal is to ensure robust science, and let's focus the discussion on that, and let's have a really open and broad discussion on that. We know that it affects all domains. You might have seen this Nature paper from 2016, where it is recognized across the domains that there is an issue, that the reproducibility problem is broad. So that's really the background for today's discussion, today and tomorrow, is how can we work together to see what are people doing, also in other domains, to fix it. How can we work together? Perhaps also have some conclusions over the next couple of days that we can also share with the world on some steps forward. So there are a lot of people doing a lot of great work, and we're very happy to be able to welcome some of those people to the today and tomorrow's agenda. So a good example is this manifesto, which is from the UK Reproducibility Network, the director of which, Marcus Munafo, will be talking to us tomorrow. Very excited to have him on board and hear what they're doing, because that's a very bottom-up approach to getting reproducibility under control. Also, the Wellcome Trust, we're very excited to have on the panel session, oh, sorry, Anne-Charlotte, tomorrow, it's tomorrow's panel session, I believe.
Tomorrow, yes.
Oh, thank you. Anne-Marie Corrio, who runs the science policy agenda at the Wellcome Trust, to hear from her how they're doing that and what we can further do together. And also Science Europe, we're very excited to welcome Bonnie from Science Europe, who's also the director there, also who have made a policy statement quite recently on this. So there's going to be great discussions, both from researchers. You'll see today we have speakers from the research field as well as the policy field. So let's keep the discussion open, broad. Try not to enter into domain detail too much when we're discussing, please, folks. Let's try and understand what are the broad concepts that we're representing there, so that we have cross-domain understanding. And ultimately, let's have a discussion that we can really take forward with some conclusions. This document, if you've not seen it already, very useful, very helpful, very practical. And we're also very excited to invite Kostas, who was the lead author on this document. He will also be part of the next couple of days proceedings. So what do we want to do? let's share our experiences, but let's have a practical discussion. Let's not make it a competition on who's prettier. Let's really talk about where we are and where the problems still lie. So really get into some good detail into what we can do, both within our domains and cross domains, to understand where the sources of variability are, understand good practices in mitigating them, and looking forward onto what those trouble spots are. Please, let's focus on the research process, not data management. There's a lot of talk around European Open Science Cloud. A lot of policy and funding attention is going to the data management part. That's great. But sometimes I personally worry a little bit. We're forgetting that there's actually a wet lab process that makes the data. And there is a big part of the reproducibility issue. So let's focus on design, funding process, execution process, and reporting process in order to look at those for the next couple of days. And let's find some common themes. And ideally speaking, if we can reach some really interesting conclusions, perhaps we can wrap this all up in a commentary paper that would be interesting for a broader audience. So we'll follow up with the speakers after that. Do please, yourself as the audience, use the chat box for questions. If the question is engaging, we'll ask you to also speak. Let's make it as interactive as possible, please. Today's program. Next up will be Philip Griven, who is the head of department of drug discovery at the ITMP partner site of the European Open Screening Platform, EU Open Screen, which is a drug discovery platform. He'll be talking to us in a moment, followed up by Francisco, who is the director of the VLB, the Very Long Baseline Interferometry Infrastructure that does astronomy. And then Andreas Fitt will be coming from the social sciences side, who's a professor of computational humanities at Claren, Eric. And then after that, we'll hear from policy, from David Miller, who's a US-based Center for Open Science, so our only non-European. So David is kindly representing the rest of the world for us on this discussion, and we look forward to hearing from him. And then we'll have almost an hour for a panel session at the end of the day. And then tomorrow we'll continue. Tomorrow's agenda, we can review that again tomorrow. Now let's focus on starting the day off. So I'm going to welcome Philip Griven to the floor. Phil, I assume you know what to do from this moment on. I'm going to just mute myself and you take over. Thank you.
Okay, thanks a lot, Anton. So I'll just share my screen. So can people see my screen and hear me okay?
Yes, perfect.
Okay, thanks a lot. So first of all, I'd like to thank the organizers for the invitation to come and speak today. And I'm going to be talking about something which is, as I guess, high on folks' agenda at the moment, is the identification of therapeutics against SARS-CoV-2, and have a bit of a dive into some of the studies that are ongoing and the inconsistencies that are rising, and then maybe some ideas about what influences those inconsistencies in the results. So I've come from the Institute of Translational Medicine and Pharmacology here in Hamburg in Germany, and we're part of the EU Open Screen Research Infrastructure for Chemical Biology and Screening. So just to set the scene, why is it that we need drug repurposing or new therapeutics when we have all these vaccines which are on the way, and we've got at least 5 vaccines approved at the moment? And in the vaccine development processes, which has been highlighted very recently in lots of channels, there's been an effort in the trials procedures to establish the safety and the efficacy and response profile with respect to age and background. But as we can still see, there's drastic needs to address production scale-up, access and prioritization, and as you've seen most recently, the influence of viral mutations on the efficacy of the vaccines. So we would certainly argue from the perspective of those involved in the search for therapeutics against SARS-CoV-2 that there's still a considerable need for effective therapeutics in the future, in addition to social distancing, the appropriate application of diagnostics, tracking of affected individuals, etc. And the recipients of these therapeutics obviously could cover individuals who have not yet been vaccinated, those who don't respond to the vaccine, individuals who can't receive a vaccine because, for instance, they may be immunocompromised, or which some of the therapeutics may, especially ones of those which are host-directed, may be less sensitive towards the emergence of mutations in the virus. So what are the strategies involved in drug repurposing to look for anti-SARS-CoV-2 and anti-COVID-19 therapeutics? So the first strategy revolves around antiviral drugs, which are looking to either block the entry of the virus or the replication of the virus or the shedding of the virus, so all the processes associated with that. And they can do that either by acting on, I'll show pointer. They can these compounds and act on the viral proteins themselves. And here, there's a very nice paper came out in the middle of last year from the Gordon Consortium. And in red here are the various viral proteins, and they're interacting with a number of host proteins. So what you can do is you can try and modify or modulate the properties of these viral proteins, or you can modify the interaction that they have with host proteins, with the idea of reducing or eliminating the virus within the cells. And you also have examples of compounds which are immunomodulators, which limit the inflammatory reaction to the infection itself, and also drugs which seek to protect the lungs via elevated oxygen supply or other ways. We'll not be talking so much about these classes of compounds, therapeutics, because those are much more difficult to assay and identify. We're mainly focused in the experiment work that I'm going to be talking about, and the inconsistencies associated with that about antiviral drugs which act either on the virus or on the host. So they are, as you probably most people know, there's a number of successes that have been come to the clinic so far, predominantly dexamethasone and Avagen, which is an antiviral compound, and Veklury, which is better known as remdesivir. So all of these have been approved for certain classes of patients, typically those ones which are in more acute situations. And in parallel to that, there's been a number of emergency use authorizations. Initially, there was a lot of hope attached to convalescent plasma. I think that's somewhat less important now. There's been less work on that, but there's still a number of monoclonal antibodies which are directed against the spike protein of SARS-CoV-2 and inhibit the entry of those. And then there's a number of combinations have always been proposed, but there are still no treatments, no approved treatments for the early stage of infection and the initial disease onset. So what I want to talk about is some of the work that we've been doing, then relate that to what's been happening in the community. So the basis of our work is looking for new antivirals or a number of repurposed compounds. So these are known or marketed drugs or bioactive compounds which have been through the clinical phases of development. So we have a collection of about 5,500, which we've got from ourselves, which cover about 600 different disease areas. We also have a collection from an EU project, Escalate 4COV. So much of this work is financed by the EU, and we're very grateful for their support. There's another 700 compounds there, and there's a set of active bioactive compounds and known drugs from EU Open Screen. And here you can see the crossover in terms of the identity of those compounds. And on the right-hand side, you can see what targets that those compounds are hitting. So these are the proteins, the disease-associated proteins that the compounds hit. So you can see in many cases there's an antiviral, or there's targets which are associated with viruses, but in predominantly these drugs are directed against mechanisms within the patient itself, so host-directed mechanisms. So I'll just go through a couple of studies. So we've been involved in 3 studies to begin with, and what we try to do within those studies is to really follow best practice when it comes to how we develop the assay. So that's the way we interrogate the biological system. So here we've got an assay against the main protease of SARS-CoV-2, and this is one of the most important and most highly addressed drug targets that are around at the moment. So we've developed an assay against that, and we can look for compounds which inhibit the cleavage of a peptide by this protease. So we want to inhibit that. So we've gone through a very concerted process, and when it comes to reproducibility, we've done things like confirming the relevance of the assay relative to standards and pharmacological controls. Then we go through an extended period of running the assay. So we run the primary screen, we find hits, we ask a set of yes/no questions, then we go through additional levels and degrees of validation of those hits up to the point where we can confirm the activity. When we start from a biochemical assay, which is an isolated protein, we can confirm the activity in a relevant cellular model. So this is what those screens look like. So you can see in terms of the assay quality of the overall process. Here's the distribution of activities on the right-hand side. This is for the main screen set, and these are the negative control, and this is the positive control. You see you've got very good separation there, so very happy with that. Coming back to the theme of the talk, well, what are the origins of variability? Well, if you remember, I said that we were using 3 libraries from different sources. And what we've actually plotted here is the inhibition of one of those sources against the other 2. So these sources, that means those compounds were synthesized in a different place under different logistics. They arrived at different times. They've been around in terms of their stability. They're very different conditions. But we can see actually we get, even though they come from quite different sources, we get a good linear correlation between compounds coming from different libraries. So that gives us some confidence about the utility of the libraries. And also we can look at the second level of validation of an assay or a screening campaign is to see, well, have other individuals and other groups already reported compounds that you also picked up. So we picked up 6 compounds within our screen randomly from the 8,000, which had already been reported in a Nature paper last year. And we were also able to show that these compounds bound, so we have a structural biology, so we could show exactly how these compounds bound into SARS-CoV-2, and we have a paper around which discusses that. But I think one of the key points to note in terms of the reproducibility and consistency is when we found the compounds, they were about 10 to 100 times more active. They had greater inhibition in our screen compared to the screen done by the other group. And there's key differences there in the way that we set up the experiment in terms of the time of exposure of the compound to the target, the temperature, etc. And all of that data necessary to make those interpretations is captured in the metadata of the assay itself. Another key thing is we didn't see a correlation between biochemical activity and cellular potency. So now I'm going to talk about a second project that we've been running, and in this case, what we're doing is we're putting the same compound set onto a set of CACO2 cells. So these are a human cell line coming from the gut, and we want to then see if the compounds are able to stop the killing of these cells by the virus. So you can see here that we've got an imaging type assay. So this is where we have no virus. This is where the virus is treated, and this is an increasing concentration of compound. You can see there's less killing of the cells. The cells appear as white. And here's the dose response, and this is remdesivir. And we measured this 2 different ways using 2 different imaging systems. And then we also have another set of, we also have a counter assay. So we want to see whether are the compounds themselves toxic just by themselves. So we have a counter assay in terms of cytotoxicity. And this data looks very nice, and you know, we get good correlations, and we come up with a number of confirmed actives, and this is now in press, as it were. And what we also sought to do was to make available not just the results of the screen, and our interpretation of results, but we've made all of these data available via the image data repository by our colleagues in Eurobioimaging, so that anybody can now come back and pick up for one of the compounds that we've used. They can look at the source images and potentially come up with some opportunity to reuse that data themselves and come up with alternative hypotheses about how those compounds may be working. So we made those source data available. So that all looks very good, and it's internally self-consistent with itself and also some reference controls. I'm going to talk about the second study now. So it's been a very busy year here in Hamburg. We also been involved in our Escalate for COV program, where we screened in a similar type of assay. So in this case, an assay where we're adding the compounds to cells where we've already added the virus. So here you can see this is a set of cells. These are green fluorescent protein tagged Vero E6 cells. You can see when you add remdesivir, the cells are healthy. When you don't have a remdesivir, the cells are not healthy, and these are our active hits. And we go through a process of subsequent validation of those compounds. So the story here is we've got a biochemical assay against a target from the virus, and we've got one phenotypic assay where we're looking at cells which are infected by the virus using a CACO2, and here we're doing the same with the Vero A6. And again, we get the same type of result as we did with our CACO2 cells, so our human cells, and these are African green monkey kidney cells 0E6 cells, which are very commonly used in antiviral work. And you can see we went through the same process. We started off with a primary screen. We picked out about 23 compounds that were active. We compared compounds which appeared in 2 different libraries, and we saw correlation. So it's all very internally self-consistent. We have this value which shows the statistical performance of the assay here, and it's the acceptable assay is 0.5, and we've got 1. So it all looks really great. So everything looks fine. So what happens then when you compare the results of this VIRO-E6 assay and the CACO2 assay? So nominally, you're measuring the same thing, but the difference is the cell lines. Now, if they were directly correlated, if the results of the compound inhibition were directly correlated with one another, one would expect to see this. But in actual fact, one sees this. So we see no correlation between the performance of compounds in the CACO cells versus the VIRO-E6 cells. And these are supposed to be the tools that the community is using to identify the new generations of therapeutics against SARS-CoV-2. So that's an extremely concerning situation. So we think, well, is this just our fault? Are we not very good at doing experiments and we're spilling the plates or whatever? But in actual fact, if you start looking into community resources which describe results from these types of assays, there's actually been multiple screens run across multiple organizations which have effectively done very similar things. These are CACO cells, CALO3 cells, VIRO-E6 cells. They've screened essentially from the same set of repurposed compounds, but these here show the overlap between the hits which are coming out from them. And you can see there's barely any overlap at all. So all of these different studies, they're all using slightly different experimental conditions, slightly different sources of compounds, and they're all coming out with actually quite different and quite diverse potential starting points for therapeutics. So how do we understand what's going on? And we have to also add here, we haven't been able to normalize this analysis due to library composition because 2 groups might be screening 2 different libraries, although there's a finite number of drugs. So we haven't been able to do that because that data isn't available. So we can't go into that level of depth. So how can we interpret this? What does it mean? So let's look at the details. Let's look at the metadata associated with these different screening campaigns and these all these references. And you can see there's differences in the cell types. There's differences in the time that the compounds were exposed to the cells. There's difference in the amount or the relative proportion of virus that was used by up to a factor of 500. There's difference in the number of days that the assays were taking place. There's differences in terms of the concentration. So it's not really surprising that you're beginning to see differences in terms of the hit populations picked up. Well, what could be the underlying biological cause of these problems? So typically there's 4 cell lines which are used commonly across the field, and they actually represent different tissues. So CALO3 comes from human lungs, CACO2 from the GI tract, HUH7 from the liver, and VIRO-E6 from the kidney. So you can look at the expression of targets, in this case TMP RSS2. That's an enzyme which is associated with viral entry, and sort of say, well, are we ever going to pick up compounds which inhibit this particular target if it's not even expressed in this cell line? And also, we're just inferring what the expression level is from public data resources. We don't know what the actual expression is at the RNA level or the protein level within the cell lines within the study. So the data is incomplete in this sense. And then we come to the famous ACE2 receptor, which is involved in virus entry as well. And again, we see large differences between the expression of these essential proteins associated with infectivity of the virus. So it's not really surprising that we begin to see these issues. Another thing that's important is cells have active mechanisms of removing compounds from within them, which are thought to be toxic. So they have this thing called a PGP pump. So what that does, it can effectively remove drugs quite quickly, and you don't get the concentration that you think you have for the time that you have. And we see again, it could be the involvement of these drug efflux mechanisms could be involved in the differences that we see between different cell lines. So getting towards the sort of wrap up of this point. So, we've been able to do this because we've ran 3 large scale screens ourselves. We've got other screens on the go, and we were able to then look into the community and look into the environment to see which other data sets are available. And thankfully, there's been a lot of work on the European and also the US side to create portals for the deposition of data. And what we've done is we've deposited all of the data from our studies in the COVID-19 portal and also into the NCATS portal as well to allow others to reanalyze it. But we try to do it at the level of the primary data so they can go back and do these types of detailed analysis of the results and reanalyze them and reuse them. So sort of final conclusions, how can we make sense of all the last 12 months in the search for new therapeutics against COVID-19? If we look at some commentary from experts in the field, from this Dietmar paper, for instance, they ran the same screen of VRE6 cells, only found a few antivirals, and they screened in HU87 cells and found 23 diverse drugs. And they found out that the entry of virus into the calorie cells depend on pH, so it depends on the local environment, and it requires the expression of this particular protease, whereas in the Viro cells it doesn't. So you're going to get a different profile of hits. And then there's another more stinging analysis by Tudor Apria and his colleagues saying there's been a big rush to publish results in a preprint format. There's some weak evidence there, and people aren't doing high quality studies and they're not depositing their final data. So I think the final conclusion in terms of reproducibility and replicability in this field, and this is news from the coal face as it were, is that we need to continue our focus on high quality studies. It's essential that we're able to reference and qualify the results that we have by having good access to primary data and metadata from portals such as the COVID-19 portal. And then we can come to a point where we can prioritize the progression of compounds which replicate, and that's replicate that as they reproduce in the different screening formats in vivo models. So it's not all doom and gloom. We do have a compound coming from one of our trials, which is now in the middle of so it's Raloxifene. It's now in the middle of a clinical trial in Italy, which is being extended into France and Spain. And this acts via the estrogen receptor. So we're trying to understand what the mechanism actually is, and we're very interested in following up that. And finally, this is a huge team effort. There's all sorts of colleagues I'd like to thank from EU Open Screen for helping us with the access to the library, through to our colleagues who are working on the virology side in Hamburg, in Frankfurt, and in Leuven, plus the guys working on the structural biology side to further analyze and profile the mechanism of actions of the compounds. So I think that's my 20 minutes up now, and I don't know, I will finish up.
Super. Phil, that was fascinating. Thanks very much. Really exciting to see, firstly, the amazing work that you guys have done in such short shrift there regarding the COVID crisis, but also the monumental issues that really look to be very difficult to sort of tease apart what the main problems are there. Feel free to add questions into the chat box. I think what we'll do is we'll save the questions now for the panel session, because I think what Phil's touched upon are some very, very common issues, probably across domains. So I think it'd be exciting to hear from everybody on the questions there, but do feel free to use the chat box. I'm now going to introduce the next speaker, who is Francisco Colomer, and he's the director of the Joint Institute for Very Long Baseline Interferometry, JIVE, Eric. Francisco, do please take the floor, and thank you very much for joining today.
Thank you very much, and thank you very much for the invitation. When I was asked to participate in this workshop today, I thought that, well, it was really an opportunity to highlight the specifics of what quality and reproducibility means in astronomy. It's a bit challenging because, well, soon I realized that some of the topics that worries us, the astronomers, are quite different to what happens in other fields of science. But it's also true that, well, as you will see, there are many points in common, and I think this is what we should be highlighting today. So allow me to start with a bit of philosophy, if I may. I mean, the science touches philosophy and touches ethics and touches other areas. And in the case of astronomy, it is really very relevant. I mean, we are in a process in which we are talking about reproducibility, which is essential to the scientific method. And actually, well, in astronomy, when we are trying to describe the behavior of nature, often we engage ourselves in discussions of things that are not always measurable. And let me just put a couple of examples here. One of them is, well, astronomy. What do we do when we are trying to understand and study the Big Bang, right? I mean, this is not a process that can be reproduced in any way. And even not going so far away in time, what happens when there is an event, a cosmic event, that only happens once, like, for example, the recent pass of an asteroid, or Oumuamua is an example here, that it was known to be of interstellar origin. And now there is a lively discussion about whether there are some hints that this could be an alien ship, okay? Of extraterrestrial intelligence origin. Now, well, Oumuamua left. It's never going to come back, and it is very difficult then, in that sense, to apply some of the standards of the scientific method to these events. Now, not only that, I mean, there is another big challenge for these physical sciences that, of course, you will recognize this in your own domains as well, and it's the fact that often experiments can only be done if you have access to very special, unique, and expensive equipment, okay? So if a team of scientists wants to replicate the detection of the Higgs boson, well, they need to have access to CERN. They need to have access to that kind of machine, which is not easy to build. And therefore, I like to highlight here that it is very important for the scientists and for the teams to have access to research infrastructures. The research infrastructures are those facilitators of best science, and indeed key for their reproducibility. Now, well, another thing very typical in astronomy is that, well, we are not patient enough to see how a cosmic process evolves. It may take millions of years to happen. Of course, we are very smart. We decide, well, as an alternative, we can study, instead of one source for 1,000,000 years, 1,000,000 sources for 1 year, and then we can do statistics on that, and it usually works quite well. But still, I think when we talk of quality, I think we have also to not necessarily look at that as an objective concept. It also is how it is perceived. And that for astronomy is getting us a lot of trouble lately. And is the fact that, well, you may have a hype in the sense that society is interested in knowing what's going on and what are our discoveries. And then to keep the hype is very difficult. And often society will not understand that we change our minds. And once we say, well, it looks like there could be life in the atmosphere on Venus, and then just 2 weeks later you say, well, sorry, we were mistaken. Maybe there's not such a thing. And also in that sense, it is important to visualize, to keep track of the non-detections, let's say the negative results. The negative results in science are just as important as the positive results, but we are usually evaluated and paid by positive results. And it is very important also not to repeat the errors and keep track of them. So that is something that I think for astronomy, due to its inspirational character, it may also be one of its major challenges to engage with society. So going to the specifics of what we work on, that is this research infrastructure. This is a collection of 22 radio telescopes spanned around the world. This is called the European VLBA network, the EVN. I was asked not to go into the technical details, but as Philippe said just before, the devil is in the details. So I will try not to be too technical. But the important thing in this context is the fact that, as you see, all these telescopes are different. Okay, we have made an infrastructure in which all these telescopes, big telescopes, national facilities in their own countries, they cooperate. They observe together at the same time. They observe the same source, and that creates a very powerful instrument, which resolution related to the distance between the telescopes. So the bigger the telescope, the more that is the network, is the best for the observation. So we have this EVN, and one of the challenges is that they have all different designs, or have all different instrumentation, but even they have different cultures. So they are run by different institutions with different funding models, different timelines for evaluation, etc. And instead of that, in spite of that, the compatibility of everything here is absolutely essential. So this is one of our most important challenges when we are tackling quality and reproducibility. So some of the elements that I think are, as I say, not only for astronomy, they are common in all our sciences. We need adequate funding. We need adequate funding for sustainability. There is an example here, a very nice telescope built in Armenia, 54 meters in diameter. There are other examples. You build the infrastructure, but then you need to maintain and operate the infrastructure. It's not just enough to go there, cut the ribbon. Otherwise, the system just does not work. We need to have then, knowledge and resources to improve the infrastructure and the equipment of that. And that, in our case, has turned out to be the main source of errors, and the main source of quality loss has been by, sometimes old equipment and difficulty in the nodes, in the partners, to improve this equipment at the same pace, at the same time, to ensure this compatibility. Then, because these are very complex infrastructure and complex systems, in order to produce the best science, user support is essential. I mean, it is very important that in the specific context of research infrastructures, we have skilled teams, experts that will guide the users in all their process of using the infrastructure. Otherwise, this is a very high barrier, and it affects the results very much. And then, well, if you look inside, if we look to ourselves, we need to take care of our teams, the human capital that we have, ensuring equal opportunities, ensuring diversity, which is very important in our teams. And also, not to forget integrity, understanding this as scientific integrity, not just the integrity of the data, of course, but also the moral or ethical, let's say, integrity that is necessary in any human cooperation. I have to highlight the need to train the staff and also train the managers, okay? Why not? The managers also need training. I am director myself, but not for a long time. And just at the time I got this position, I was engaged in a master program that I want to mention here, the Executive Master in Management of Research Infrastructures, MMRI, which is done at the University of Milano, Bicocca in Italy. And there you get a very nice overview of everything that needs to be understood that happens in a research infrastructure: strategy, finances, services, human resources, communication. Of course, you don't become the expert in any of these fields, but you are skilled enough and knowledgeable enough to understand what the experts will do in each one of these fields in your infrastructure. And that is, I really encourage people to take care of also training the managers. And as I said before, how quality is perceived? Well, the management of the expectations. What is it that we think we can do, and how we communicate that to the others in order to prevent wrong questions? Okay, wrong questions meaning that we are not asked for the reality of our work, but what people think, maybe wrongly, that we are working on. Okay, how to improve quality and reproducibility? In our case, as I said before, one essential point was to improve the infrastructure, therefore have a state-of-the-art instrumentation, better monitoring, calibration, reduce, in our case, because we are radio astronomers, the radio frequency interference, which is very strong. You see a plot here that when you're trying to detect a very faint galaxy at the edge of the universe, the worst of your enemies is the vacuum cleaner, okay? That is just creating RFI. And then in our case, also a boost in quality has been the improved connectivity of the telescopes, which is the possibility to do observations in real time. So the observations are sent to the processing center, which is GI, which is where we are in the Netherlands, and it is done in real time. So we can spot problems as they happen. We don't need to wait maybe weeks before the data comes in order to analyze that. There is also improvements in the data analysis processes. That I think is common. Have data reduction pipelines, expert support, as I mentioned, and have that linked to the data. So the data, the metadata, has to be accessible. We say fair. Has to be linked to the archive. The archive has to be open, has to be linked to the publication, and all of that is going to help the reproducibility as well. We have been working in astronomy for many years in a concept that is, well, a precursor maybe of EOS, that is called the International Virtual Observatory Alliance. And that is, that is a tool that allows us to combine the output of different astronomical techniques and then boost the results in this respect. Not so easy to integrate the radio astronomy there, I must confess, and that's why we also are developing a project called Escape, that is Horizon 2020, and that helps us in that aspect. The last of my slides is about this very exciting initiative that we are setting up, that is called the Global BLBI Alliance. This is to combine or let's say collaborate the different networks of telescopes that exist around the world. We have the European network, as I said, but there is also one in the Northern America, in the USA. There's one in East Asia. There's one in South Africa. There's one in Australia. And we want to share information between all these networks. We want to offer expert support to the users and to make this technique visible and an easy entry point to non-experts astronomers. And also, sometimes we want to use this to coordinate joint observations. Even if this is not the main goal, this can also be quite interesting. So my conclusions, well, of course, what can I say? If we want to study things like multiverses, is this real science? Do we need a revision of the scientific method? But then when we go to the practical things, there are limits on the reproducibility. We need research infrastructures to facilitate access. We can reproduce the processes of analysis if we have access to the data, to the metadata, and all to the pipelines and to all the different let's say processes, including the publication of the results. We must also pay attention to the negative results. And for research infrastructure in particular, we need to train the staff and provide expert support to the users, as we say. And also in general, if we want high quality science, we need to take care of people. And that means ensuring a career path for scientists, having stable careers, reasonably paid, fair evaluations, which is today a challenge, ensure diversity, etc. Thank you very much.
Marco, thank you very much. That was fascinating and a lovely blend of science and philosophy. Thank you. You finished really well in time, so I think we can ask a question or two here. That would be great. There are no questions on the chat yet. Do please ask questions if you can think of something of interest. I do have a question for you. You mentioned very good points around the training of staff. In years past, I've had discussions with other life sciences infrastructure managers, and what we see as the academic mandate to publish sometimes causes a bit of mission creep when it comes to the usability and the validation, the desire to really validate and prove the utility of knowledge to society. The idea of a staff scientist who's not held back by the academic mandate, but is there truly as to be the technical expert and to be a scientist on staff whose mandate is purely driven by the science itself and not any pressure to publish. Is this something that in your field comes, you come across these positions a lot, or is it mostly academic work?
I'm afraid we have quite the same problems that everybody has. I mean, we as a research infrastructure, we have service staff, And but well, most of the service staff, especially those who have a scientific background, including myself, we love to do science. Okay, so we always have this compromise, right? What we do in our case is for those who don't have a permanent job, a permanent contract, we offer a minimum of 50% of time for their own science. So they are never charged for more than 50% of service. But yes, we have to provide service. Okay, so I think this is one of the big problems that I think we suffer. There is a lot of pressure on publishing, and that is affecting the quality necessarily. The fact that we publish more does not mean that the quality of the science is better necessarily. Okay, and we have to really think, and there are a lot of people thinking on that. Okay, but of course there is an inertia and there are other interests. And we have to be finding creative solutions that are first good for science, but also understanding that we don't live in a bubble. We need to get in contact with all these other partners that are also important to us.
Indeed, indeed. I see a question from Nicholas Pade of EMBRC, who's asking about the negative results issue, which, as he rightly says, has been around some time. But why are we not sort of improving this issue of making that sort of data and negative results available? And what can we as research infrastructures do with this? Any inspiration for us, Paco?
Well, I have, of course, had dozens of examples myself in which I had my proposal to this big telescope, and then I did observation, and then I did not detect what I wanted. So what happened? Well, I didn't publish, and then immediately I thought maybe this had been done by somebody before me, you know, and I could have avoided asking the same question again, because how would I know, right? I think it's a problem. I think it is really important to track the whole of the scientific process, including the negative results. This is part of the science, and we don't have a solution. I mean, as long as we depend on the evaluation by publishing in the high impact journals, I'm afraid we are quite trapped, and we could have alternative. I mean, open publication is becoming more and more popular, so maybe through open publication, it would be like archive or things like that. It could be possible to publish these negative results, and then we need also, of course, to put some value on that. We need the evaluation process to take care of that as well. All right, and then yes, I think that there could be a future.
Indeed, yeah. So that incentivization, that would be the key. This is an open call to any participants who are aware of initiatives that incentivize publication of negative results. Do please let us know. That would be very interesting to hear today. Either put it in the chat or flag that you would like to chat, and we can unmute you. Paco, thank you very much. Really stimulating. Look forward to more during the panel session. I'm going to now hand over to the next presenter, which is Andreas Witt, who's a professor of computational humanities and technologies at the European Infrastructure for Language Resources and Technology. And he's at the Leibniz Institute for German Language and Digital Linguistics. Andreas, do please go ahead. We would love to hear from you. Thank you.
I would like to talk about the case of reproducibility and also sustainability in distributed research infrastructures. And I talk about the perspective from the Clarin ERIC. As you have seen, it was the second ERIC that has been built up, and the talk is by Dieter van Uitwank, who is also attending here, and myself. Clarin, what is this? It's not astronomy. It's not nature science. It's from the humanities. It is Clarin stands for the Common Language Resource and Technology Infrastructure. As mentioned, it is an S3 ERIC since 2012. And what do we care about? Well, the most important thing Clarin tries to solve and to offer is we provide an easy and, this is the reason for reproducibility, sustainable access for scholars in the humanities and the social sciences, mainly to make use of digital language data, but also beyond this use. So digital language data means we deal with written, spoken, video, and multimodal data. And one could also say, well, I never compare this to the non-reproducible Big Bang just mentioned, but language data is per se in many cases not reproducible. In extreme cases, we deal with language data from endangered or also extinct languages, but each and every single language occurrence is somehow unique. So we use advanced tools. We try to discover, explore, and exploit this data. And to do this, we annotate the data. And this is done in an infrastructure. And this is a single sign-on online environment. One of the most important and necessary challenges in this field is that we have to deal with a distributed infrastructure. So it is not possible to distribute, to send the language data to, say, one huge repository, but many centers, many groups like to keep track of their own infrastructure. And in the consortium, we currently have 25 members. So in the ERIC, we have 25 members and 3 observers, and we have one third-party member. So most of the members, of course, are from Europe, but we have also observers from South Africa, a very multilingual area. And we have also one center in the US that is specialized for dealing with child language development from children. Clarin is, of course, organized as a network, as an ERIC, but it is also connects several independent centers, so-called Clarin centers. We have different types of centers. We have so-called B centers that provide services, and these centers are certified centers. I will come back to this in a minute. We also have C centers that mainly provide metadata, and we have something what we call K centers or knowledge centers that are part of the knowledge sharing infrastructure. And in addition to this, we also have some external centers. So what means certification? This is one of the clues, one of the key aspects of sustainability and also reproducibility. So the centers keep track of their data, and we have to make sure that the data does not, in a way, get lost because simply a center is going to vanish. So therefore, Clarin installed certification, an assessment certification process. Sorry, am I audible?
Yes.
Yes, you are. Yes.
Yeah, I heard some. Okay, we have a certification procedure, and each of these centers apply for becoming such a B center. There's each of these assessments is valid for 3 years, and we have an internal procedure that makes sure that these centers will sustain for at least 3 years. And after 3 years, this process runs again. So the assessment procedure is a 2-step process. First of all, these centers have to get the core trust seal. This is an external group that offers a certificate for trustworthy repositories. And based on that, Clarin assessment takes place that makes sure that the center not only provides language data, but also makes sure that the organizational issues are solved in a way that these centers will sustain for at least 3 years. Clarin also supports some workshops. So in language technology and language science, reproducibility of research results is a big issue, as in all other research fields, as we have learned some minutes ago, and before as well. And there's one workshop series that especially deals with reproducibility for language, computational linguistics results, and this can be found at the Clarin page. So what's the data architecture? So reproducibility depends definitely on organizational and also technical solutions. And what is the technical solutions provided by Clarin? So the language data are collections of language material, so-called corpora, but also lexicon, or lexical information systems, grammars, and the like. This is the language data. These go into a repository together with the metadata. And moreover, we also have tools that deal with these language data, and these tools should also have metadata, should be findable, and should be accessible. And in a way, the language tools should be usable for the language data. Of course, this has limits because not all the tools can be used with all the data, but essentially this is the ideal situation. We provide persistent identifiers for all this material. So reproducibility without finding the data and being able to address the data is doomed to fail. Therefore, we make heavy use of persistent identifiers. We have metadata with fixed header, and we have handles. In our case, we use handles, so some PID mechanisms to not only point to the metadata, but also to the language data and to the tools. So when trying to discover data in our repositories, we make use of a harvesting mechanism, and this harvesting mechanism yields to the result that all the language data available are stored in our so-called virtual language observatory that points to the individual language resources at the individual centers. For PIDs, for persistent identifiers, there's also organizational setup necessary. So the centers are free to choose whatever persistent identifier scheme they like, but they have to make use of one, of course, or at least one. In practice, most centers make use of the handle system, and Clarin itself is also involved in the development and the organizational background for the handle system. We work in the EPIC consortium, but some also make use of document object identifiers, so that's fine. But PIDs is one thing, persistent identifiers, but it's just trusting that they really work. So at some points, especially in this distributed environment, it is necessary to check these links. And since we have millions of these persistent identifiers and we have millions of these links, on automatic checking is necessary, and this has been implemented in Clarin. So it's a resource-consuming activity, so it costs time, it costs implementation effort, it costs computational resources, but it is necessary because reproducibility with broken links is simply impossible. So I will end with some specific challenge in reproducibility for language data. It is rare, but we have to deal with this problem as well. As I mentioned, language data is produced and is sustainably stored.
So without any further ado, thank you, I welcome David Miller to the floor, who is, and let me get this correct, please, Director of Policy Initiatives at the Center for Open Science, based in the US. I hope you're East Coast, David, so it's not too early for you. Very good.
Perfect timing.
Great. David, you are our ex-Europe representative. No pressure. Thank you very much for your time. Looking forward to hearing your story.
Thank you so much for the invitation. I hope everyone can hear me. If you can't,
yes,
too bad. So thank you very much for the invitation. As I said, my name is David Meller from the Center for Open Science. I'm going to share my screen in a minute, but I just wanted to introduce us as an organization. We're a nonprofit organization located in the US with a mission to increase transparency and reproducibility in scientific research. And here we go. Hold on one second while I share my screen. I'd like to start off by giving sort of an explanation of the problem statement that we often focus with. And that is the distinction between the norms of how science is sort of expected to work and counter norms. And those have been laid out for many decades, but very, very briefly, those norms of how scientific conduct should be conducted are all about open sharing of evidence, being skeptical of new evidence, and emphasizing quality over quantity. And of course, the opposite of all of those counter norms, being secretive, being dogmatic, being focused on one's career over the scientific rationale and questions, and focusing on quantity over quality. And Anderson and her colleagues asked a few thousand researchers a few years ago to ask them, tell me the degree to which you subscribe to the norms of essentially open scientific practices as compared to those counter norms. And the vast majority, over 90% in that light gray shaded region, said that they subscribed to, they bought into those norms of science over the 1% or the 2% there that bought into the counter norms. She then asked that same group of researchers, don't tell me what you kind of believe in, but tell me what you practice. And a good majority still say that they sort of practice those norms of scientific research. That hashed line there is the 20% or so that kind of admit to having it a little bit of both ways, sort of in the middle of the road, doing a little bit of each, and about 5 or 10% admit to practicing according to those counter norms. And the real key to this survey was this last question coming up. Don't tell me what you practice, but tell me what your peers practice, or tell me what the colleagues in the other department or those who you're competing with jobs for practice. And the key here is that there's a wide perception, a majority of individuals think that their colleagues, their peers, those jerks in the other department are practicing according to the counter norms of scientific research. And this really presents a challenge for culture change. If you believe, as many people do, that everyone's kind of in it for themselves, nobody is as open and transparent as they should be or could be, then it creates this real sticking point where it becomes, there's a strong perception that doing what's good for science is bad for you as an individual. And that's a real sticky situation to be in any movement that wants to improve or change a scientific community or norms or culture. So not only is there kind of an incentive to act against those norms of scientific research, but there are opportunities to do so. So you can think of a simplified, idealized process of scientific hypothesis testing, confirmation and discovery, generating specific hypotheses, designing and conducting a study, analyzing and interpreting the results, and using those to generate new hypotheses for a kind of a virtuous cycle of explanation, discovery, confirmation or rejection, and repeat. Each of those points in the scientific virtuous cycle can can be undermined by so-called questionable research practices or just bad practices. Data dredging, p-hacking, hypothesizing after you see how the results of the data analysis look like, so-called harking, conducting many low-powered studies as opposed to a fewer number of larger studies with larger sample sizes. Each of these undermine the idealized way that much of this research should be conducted. And not only do we know that that's hypothetically possible, but surveys confirm that many of these practices, when are simply self-reported to occur. These are across 5 different disciplines in a few different regions: psychologists, biologists, researchers in education science. When asked the degree to which they participate in one or more of these practices, many of them will self-admit to conducting it. So we know that there's an incentive. We know that there are opportunities to practice some of these less than ideal practices, and we know that people admit to doing them. The cumulative result of that and other practices I'll talk about in just a second is a body of research that's more difficult to replicate than it should be, with several large-scale attempts to measure how reproducible a body of work is, finding that more often than not, empirical research findings cannot be reproduced or cannot be replicated. But there are many possible reasons for that. Some of them are good reasons, and some of them are bad reasons that we want to minimize. So incomplete methods reporting, you can, once you try to replicate a study, only then can you sometimes figure out, oh, there really isn't enough detail in these method sections to pick up where somebody left off. I already mentioned a lot of these questionable research practices. And there's going to be statistical noise. Either replications or originals are sometimes going to be false positives or false negatives. But the real good reason that we want to really focus on, the reason why replications should be done, are so-called hidden moderators or new discoveries. If an original and a replication study come to a different conclusion, it might be some unaccounted for variable, some unaccounted for difference that was previously unknown, and that's a new discovery that deserves to be emphasized. We can minimize those first 3 through open science practices: better methods reporting, more use of materials and data sharing, pre-registration, which will be the focus of the second half of my talk, can minimize the so-called bad reasons for a replication failure. And that way, when replications do happen and they come to a different conclusion than an original study, we can be more certain that it's because of some unaccounted for difference, some new discovery that deserves to be the area of focus. And we won't get into debates, or we won't get into arguments about blaming individuals for sloppy methods or whatever unproductive conversations might often happen when replication studies occur. So there's a template, there's a guide for how culture change occurs, and it's been found in many different situations when new innovations spread throughout a population. It's going to follow a bell curve trajectory of adopters. There's a small set of early adopters and innovators who are the first to pick it up, even if it's brand new or difficult to use or anything like that. An early and late majority will start picking up as more and more people, as they see more and more of their peers doing it. And then the later majority and those who hold out the longest might come kicking and screaming once they're required to do so. So we can pick up that method, that roadmap for changing a research culture, and apply it to activities. We do that by building infrastructure to make activities possible. Of course, we're not the only ones to do that, but when something exists that makes it possible to do it, the early adopters, the innovators, will be the first to do it, no matter how hard or easy it is to do. Making it easy and sometimes even fun is a way to pick up a larger group of people. once people see norms shifting, a larger majority of individuals will come along. And once these activities become recognized and rewarded and even required, picks up the last few folks. There are many organizations working on a variety of these types of tasks. These are some of the ways that we at the Center for Open Science are supporting these different types of activities. So we build infrastructure. The OSF is an open source online platform for enabling the types of activities we advocate for: data sharing, collaboration, pre-registration. We're involved with a lot of communities to share practice and show that these are becoming more and more normal. Badging program to show, to make more visible the types of behaviors we want to see happen. Publishing and funding format called registered reports, where idealized practices are the ones that are accepted for publication or for funding, and then policy recommendations. I'm going to give a case example of applying this framework to the practice of pre-registration. So I'll show different ways to make it possible, easy, normal, rewarded, and in some cases required. Pre-registration is the act of specifying in a registry, public, maybe after an embargo, but eventually a public registry, that a study is about to be conducted. And ideally, it'll include a very clear analysis plan in order to help make a clear distinction between those confirmatory hypothesis tests that are listed before you see the data set, and make a clear distinction between those with exploratory work that's designed to generate new exploitations that deserve later confirmation with a new round of data collection. The distinction between these two is critical to maintain in order to preserve the benefits of both. When one is in the context of confirmation, this is traditional hypothesis testing. P-values are still quite ubiquitous in many scientific endeavors, and they retain their value when the hypothesis was fully specified before seeing the data set. And we do want to minimize false positives when we're trying to confirm whether or not something is real or not. Keeping that distinct from the context of discovery, where we really want to minimize false negatives. We don't want to miss a discovery that was unanticipated. We want to find unexpected trends, but these are not hypothesis tests. The probability values don't make sense in this context. And pre-registration is designed to keep these two modes of work distinct and separate. And it's because of the fact that presenting exploratory results as if or using tools designed for confirmation makes the work seem more surprising or publishable, but it comes at the expense of their credibility. So that's the real crux of the situation and the reason why pre-registration is so vital to this. There are a number of ways that it can be made possible and easy. So there are a large number of study registries. Sometimes they're discipline specific, sometimes they're generalist repositories. The one we build and maintain is the OSF. And this is a process whereby an individual can go into it, answer the questions on the form, and the result of that is a time-stamped read-only version of the research plan that can be publicly available immediately or after an embargo period. And it's designed for many folks who haven't been asked to go through these levels of detail before. So it's a step-by-step process of asking the researcher specifically what type of data are going to be collected, the degree to which data may be available or not as of the moment of registration. And there are a couple of different levels for each of those. The analysis plan is the point in the registration process that is often thought of last, because in the most typical workflows, we will often only think of how precisely we're going to analyze the data once we really get into it and collect it. So this is the point in the registration process that's really designed to slow us down and make us think ahead of time about the proper way to do it. And at the end of that, as I mentioned, there is a time-stamped read-only version of the research plan. These practices are becoming more and more normalized as communities see the value of the process for their own purposes of planning and for helping, remind ourselves precisely what the context of the study was as we go through it. There's a couple of different initiatives that show this. We are seeing a large growing number of registered research plans on our platform. These numbers are a little bit out of date, of course, from 2018, but we see that continuing to grow with about 50,000 registrations made last year. Individuals see these behaviors as becoming more normal when they see their peers picking them up. And one process by which that is facilitated is the badging program. So this is a screenshot of the table of contents of one journal, Psychological Science. Those little red icons on the screen are studies that involve one or more pre-registered confirmatory hypothesis tests. And each one of those becomes an example for a peer to follow or emulate or learn from. There are a variety of institutions and processes by which pre-registration can be recognized and rewarded. So I already mentioned that the badge itself is a little bit of recognition and reward, and we see the number of studies in one journal with one or more pre-registration rising over time as those indicators, those badges are being provided. There are universities that are recognizing the process of pre-registration in hiring and tenure decisions. I'll mention what registered reports are in a little bit more detail in a minute, but it's a way to reward with publication the act of registering and sticking to that registered plan. Registered reports are a publishing and in some cases a funding format in which peer review occurs before the study is conducted, often before data collection starts, but depending on the precise mode of research, sometimes after it. The first proposal is sent into the journal, and it often will look like a normal research article up to the point of the results section. And the editors and reviewers are evaluating the questions of whether or not the hypotheses are well-founded. Are they sufficiently detailed? Is the study highly powered? And the last thing that they often check for is one of the most important. Have the authors included quality control checks or positive controls to make sure that the study provides a fair test? If yes, the study is granted in principle acceptance, a promise to publish the results regardless of the outcome. And then after the study is conducted, that second round of review just confirms whether or not the authors stuck to the plan and if the conclusions are well justified. But importantly, not whether or not the hypotheses were supported or significant or novel. And finally, there are a number of situations in which pre-registration may or should be required, especially for inferential hypothesis testing research. So we have a couple of policy recommendations for journals and funders. A number of journals and funders apply that level 3 rationale of requiring pre-registration. We surface journals that encourage or reward or require pre-registration through our work with evaluating journal policies against these recommendations. Topfactor.org is a database of about 600 journals right now, and evaluates the degree to which they encourage or require disclosure of open science practices, such as pre-registration, or require or verify those. So that's it. That's all the time I have. I'm very thankful for the invitation. Please take a screenshot of this if you want to preserve the links, and I'll put a couple of these links in the chat window now. But for right now, I will stop sharing my screen.
Super, David. Thank you very much. Very interesting, and it sounds like a very, very worthy initiative. Lovely to hear from you over the water. I think the time now is perfect for us to move to the panel session. So stay online, David. Stay with your camera on, please. I invite all the other speakers to do the same. And we also have an additional speaker that we welcome to the panel session, who is, I'm trying to find my text here. So Raj Long, who has come from the life sciences field to join us today. Raj is a regulatory expert with 25 years experience in the drug development process. Obviously, that's a very relevant area for us today, particularly considering the high amount of evidence required for the drug marketing authorization process, but also given the context of the COVID crisis. And with good fortune, Raj is also supporting the WHO on COVID as a consultant advisor at the moment, and has plenty of history as well, working in advisory roles in the Horizon 2020, NICE and EDCTP and the UK government. So Raj, do join the session, please. We know that you can't use camera, we're aware of that, but we hope you're online. Do you hear us, and can we hear you?
Yes, I can hear you really well. Good afternoon, everyone. Apologies for the lack of camera. I decided to not work today, so we went for the easier option of just audio. So again, I just want to say thank you to Anton and the team for Beatrice to be given this opportunity to contribute to a very, I would say, really informing and wide array of topics this morning. Everything from astrology to health, so fascinating. Thank you.
Indeed, thank you and welcome. Yeah, let's jump right into it. So we do welcome questions into the chat box, please. So that would be very helpful. So I actually had a question pertaining to this last presentation from yourself, David. So the pre-registration, it seems like such an easy fix in that it's not a high resource intensity, but it does, lock in so much integrity in that step. Why do you feel that the uptake isn't instantaneous to 100%?
Yeah, I think there are a lot of possible explanations for that. In some of the first reactions when we have discussions with this is a perception that it's that it locks one into a very specific research plan and prohibits the type of discovery and flexibility that we're often used to. By design, it does lock in some, but it encourages that type of creativity and exploration that we're used to in the second half of the kind of results section that will come for it. So it's a new way to think about how studies should be conducted and results should be interpreted, and that's not intuitive to many hearing it for the first time. It does start a research project a little bit slower than we're often used to it. So writing the analysis plan can take, oftentimes a lot of time. And that's at a point when somebody is really excited to get started with the project. So I think those two things are some of the initial barriers. But oftentimes when people have done it once or twice and they go back and see the analysis plan that was written and thank their previous selves for having written it ahead of time, there's often that benefit of hindsight that comes up.
Understand. Thank you. Does anybody on the panel have experience of actually using the pre-registration concept in their research or is aware of how it's run? It'd be interesting to hear actually from the field. Anybody in the audience has experience of pre-registering their research? Okay, that's one thing for us to follow up on to find out what's holding people back there. Thank you. If I may, I'd like to go to Phil, to your presentation and to the COVID discussion. So it was really interesting to hear, the issues that you found. I mean, conducting really two very high quality experiments where you think there would be a little bit of overlap in the results and you didn't really find that. So I think COVID has really put research up to the light in a lot of positive and a lot of negative ways. What's your biggest learning from this experience that you've had, knowing that you conducted the research to high quality and yet you still suffered from the inability to compare those results?
Yeah, I think that's a good question. I think the situation whereby we can actually identify if there's issues is when we have access to primary data from other investigators. So if we had only made that observation in isolation, then we'd all be looking internally and trying to find out what was wrong with our equipment. But the reality is that if you are able to access the community-wide results, the positive and the negative results, then that helps you in order to try to at least understand what's going on. And there are a number of initiatives. You know, we're not the only person to have identified this. There's a number of folk, especially at the organizations which are aggregating data sets. So the guys in Kemble and the guys in NCATS are organizing a workshop on this topic. We'll hopefully be able to contribute to it. And you know, what we want to be able to do is that when it comes, I don't think it's going to solve. We're not going to solve any problems with this pandemic. I think that the horse is bolted to a certain degree there. But when it comes to pandemic preparedness in the next round, it's learning the lessons of what's happened in the last year, and then seeing whether we can put in place some at least improved processes and guidelines and standards that labs need to adhere to before they start churning out data sets that could be potentially picked up and used by others in a way that it wasn't originally intended. So one can think of many examples of that, and I'm not going to say hydroxychloroquine too loudly on there, but we know that our in vitro assays using CACO2 and CALO3 cells don't pick up hydroxychloroquine, but Vero E6 cells do. So there is you know, an opportunity to I think to learn from what's happened in this space, and but it's probably too late. There's too many ongoing studies. There's more than 50, 60 therapeutic studies which are ongoing at the moment. So you're not going to influence them too much, but it's what we do in the future. And from what I understand from seeing future funding calls, I think the focus is going to move towards solutions in that space.
And to how much of this is avoidable by initiatives like ring testing, like proficiency testing of your systems? Is that a part of the solution and only a small part?
No, I would actually. I think that the gaps exist elsewhere. So I mean, what is quite evident is that the source of compounds coming into repurposing has come from sort of two sectors. Yeah. One has been the sort of hypothesis-driven testing in a cell model type activity that we have. Here's a target. Let's look for compounds against that target. And the other has come from an analysis of clinical data from patients who present who might have lower rates of hospitalization or less severe disease, and that's linked potentially to the medicines that they're receiving. Now, apart from a few very limited examples from what I've seen in the literature, there's been very little cross-pollination between those two communities. There's a couple of papers come out of the US where they have better access to clinical data than we have, but we would certainly love to be able to compare directly large-scale clinical data sets and understanding what outcomes were for people who were receiving a particular therapy, and linking that through to targets that we are picking up with the same compounds in vitro screens, and then trying to build hypotheses around how the compounds are working on that. So I think the limitations, coming back to your question, the limitations I think relate to the access to information, high quality information, good data, and then being able to make that leap from your domain, and our domain is screening. I work in the world of microplates and microliters, yeah, but being able to get access to information from other domains and allow you to sort of build testable hypotheses that and then go through rigorous clinical trials and subsequent evaluation. So I think that's where we need to improve the way we do things in the future.
Thank you. And to Raj, who's having to be be aware of all of these findings that are coming from the field, and then use that knowledge and to give advice to an organization like the World Health Organization, obviously whose policy will have enormous global impact. Describe to us the stress you feel of having to understand
on a daily basis.
Data.
Okay. Stress on a daily basis. And I mean, that's what COVID has given us for the last year and a half. So the first thing I want to say is anything I'm going to share here clearly is not on behalf of the World Health Organization, for all the obvious reasons. So it's essentially just the knowledge I've built up and the experience I have. I think COVID, if I look at COVID at a sort of a strategic level, it has been a massive disruptor. And I think everybody agrees on that. But I also think it's been a really good example of an accelerator. We have not seen in the history, I would say since the Spanish flu, because we didn't, we're going back many decades here when probably none of us have been around, where a development of a vaccine happened in less than a year from start to end. If you look at it just from a research and science perspective, it absolutely was a fantastic example of an accelerator. And I asked myself, why does this happen here? But that's because, as many of the points a lot of the speakers today discuss, is a coming together, they're integrating, having a common goal, willing to share good or bad, And I think that is a key piece that often gets missed when I look at research in a wider area. And I think, if I hear what Francisco touched on, Philip touched on this morning, around example of sharing of negative results, that's been historical in the research community, that's not new. And if you ask yourself yes, it's a culture, but culture is often, set by expectations. So in many ways, as a research community, you set your own expectations. And if you look at COVID, and I listened to a lot of things that Philip talked about, maybe it's time now to, to accelerate something else that is change the culture a little bit. So even when you are setting your research questions, traditionally, historically, we tend to set them to prove something, confirm something, right? That's kind of how we've always done research. But I think what COVID has shown is the variability and the unknown and the speed with things evolve there. That maybe in something like a pandemic response, when you're building a hypothesis, it cannot just be confirmatory. You also build in exploratory. I know, David, that's kind of contradictory to what you said because they're a little bit separate. I think in the normative state, yes, science is pretty clear cut. But if you're trying to study a target that's evolving, and we really don't know much about it, and we're trying to keep abreast, of the virus, which is beating us in multiple fronts, maybe there is room here, in how we look at research, and go back to some of the basics and say, do we set our research questions in such a way that it advocates success, but it also advocates how not to do things? Because suddenly now we have turned both into a positive spin. Sharing the latter has to be advocated. It's not going to happen dynamically. So, Anton, back to your question, yes, and I see this in multiple areas of studies. And the other piece, just to add specifically to COVID, because I think COVID is so current, and no matter how experienced you are in the field of research, we're learning still a lot from COVID, which are all new areas, in terms of it. So maybe one of the areas as academic researchers that I see, and here I'm coming from a regulatory sense, and Anton, you've heard about this in our other project that we work on. You need to get organized, Critical mass is important. Having a common integrated goal is also critical. But think ahead of whether you're going to have a viable product. Even in the work, Philip, that you talked about, one of the questions that was going through my head is, how was this shaped during the research phase? That if you did see success, would you be able to go to a regulator and say, hey, we've done this to all of these standards. How can we make this? The viability of the work, that can then evolve into a viable product in a very quick time frame, like in the context of COVID, is an aspect I often see missing in academic research, or not enough. Because it's your research has to have an end state if you're looking in the context of health and disease, So over.
Thank you, Raj. Very clear, very good, nice summary of the field of work there. So that mandate that you're talking about, I think that's an interesting point of discussion. Who owns the quality issue? Because what I get a sense of sometimes is that it's not really owned by anybody, and because it's owned by everybody, and so nobody puts specific focus on it. And for me, in our experience, certainly in IATRIS, we see that when we bring up the subject, everybody agrees it's a very important subject, and then moves on to the next subject. And the question is, so how do we get all the different actors, including the research funder and the publisher, to work together towards some practical solutions? And I think we're hearing today of some of those already, and also tomorrow we'll hear some more. So maybe I'll put a question to Paco first, you, and then Andreas. If you were to be given the pot of European Commission money and be told, okay, now give us your top 3 policy interventions to increase the robustness of the research results, what would you put your focus on?
Well, obviously not an easy answer, okay?
Yeah, of course.
But it is true that there are, I think it's been touched the base today in several cases. I mean, I even mentioned about if quality is an objective thing, and it also depends on the perception, right? I think quality belongs to the society at large. I mean, it is, of course, a responsibility of the scientist, and we have some tools for that. But it is also something that the society must demand, and the society must understand. I mean, we as scientists have some rules, scientific method, and all our policies and so on. But often we fight with an expectation. As I said before, for astronomy is to me very obvious, but maybe not very critical. For many of the things that are happening today in COVID, for example, they are very critical, and it is what does it mean for society that the work of the researchers? I mean, we are just hearing that we are expected to produce something that can be made a product. Okay, is that actually part of the ultimate responsibility of science? I would say yes. Okay, but it's not the final justification. I mean, we don't do science because we want to create something that can be then put into the market, right? Of course, we will never forget that. But the question is whether we as a society need to give a science a value on itself, and this search for this curiosity-driven research, right? So, and it is a complex discussion. I don't think it is. We are far from having reached even an agreement among ourselves. But then it comes the issue of education. We need to engage with education of the society at large, so that everybody understands what scientific method is about, what are the limits and the context in which we are operating.
Mm-hmm. So interesting. So you propose society at large for the education. So not just the researchers themselves in terms of the technical, but really society at large, managing their expectations of what science can deliver, yet keeping the balance of also inspiring them to keep funding it as well.
I defend a lot, and I'm not very original here, that science is part of culture. I mean, we often say that people who have culture is because they know about history, literature, and art. But what about science? I mean, if you don't know anything or not sufficient about science, you can hardly call yourself an educated person. And that's unfortunately very often happening.
Indeed, indeed. Thank you. Andreas.
Yes, I fully agree with the things Paco mentioned, but there are also some issues we have to ask ourselves. We as the researchers. One of the problems with quality and sustainability is that quality is in a way taken for granted. Nobody is going to question the truth of a result. Only a few people try to reproduce a certain result because it has been published in a journal. It has been presented at a conference, and of course, only a few of us doubt this. And this is one of the problems. Having a bit more critical view on some of the results would probably help to in a way have a closer look to some of the results and not only trusting the reviewers. This is one of the issues. And in a way, very close to this is also the fact that you also asked for funding. Funding is in most cases bound to ongoing projects. You get funding for something that is ongoing. Of course, you will have results and then you write your final report. But reproducibility comes after that. And who is going to fund sustainability? Who is going to fund making data accessible, say 10 years after a project has been finished? Okay, we do have some archives, we do have some libraries, but there is nothing research driven. So this is some of the issues. And if you ask for funding, I would like to see some programs, at least pilot studies, that deal with such an aspect. I do not have to repeat what our colleague from the US said, but pre-registration of research is also a very important thing. So this would I would really love to see this happen, because only in this case we see, in a way, not successful research. So this is for me the only possibility to see this. Yeah, these were my three issues on that.
Fantastic, thank you. David, you referred to Tamarind Haven. Tamarind, are you on the call and able to talk? We'd love to hear from you.
I am on the call. Thank you, David, for giving me the floor. And I think it extends a little bit to one of some of the previous speakers also already said, given the diversity of disciplines that we have seen represented here today. And I think also within the sort of health sciences broadly, there's more and more attention for qualitative research. And I, together with some people, have worked on adapting the pre-registration formats that were out there in a way that they were also meaningful to increase the transparency of qualitative work that some of us may be conducting. I hope that's a sort of helpful small addition there.
Indeed. Yeah, that is very helpful indeed. Thank you very much. Nice to hear from you. Thanks. Raj, may I ask you, now, so in the process leading up to the marketing authorization of a new drug, there's a phenomenally complex and highly regulated research process, right? The classical phases of research. So very well described how you need to register and have QMS, quality management systems and everything like that. Would you see development of these kinds of standards, or not necessarily so onerous, but in preclinical research as a route to improving quality? Or does that bring the whole system down simply because you'd eradicate the creativity that comes with exploratory research?
Great question. In preclinical research, certainly for human medicines and vaccines, on that field, you have something called good laboratory practice. It's called GLP, and it's specifically designed to complement what you do in the clinical phase as GCP, good clinical practice. They're very similar principles, but they are a set of core standards and requirements that ensure quality. But that's very much limited to, in the context of medicines and vaccines, that world. I don't know what's outside it, but those principles are very, one could look at those principles and see how can you apply that elsewhere, because laboratory work is, consistent in that way. If you're going into research, certainly in that field. I don't know if that answers your question.
Indeed, yes. Thank you. Appreciate it. Now, I'm going to take a tour of the table here. Please give me your top two areas where it's still a major issue for you, because there's a different types of non-reproducibility, right? So the methodological design, the choice of reagents, what's it called when you check the machine is running at the right level, for instance. Perhaps in your experience, where do you face the most troubles? Where would be the most interesting place for the community to come together and really look at how to resolve those long term? I don't know if we have a volunteer to go first. Phil, please go ahead. You're on mute still.
Yeah, you just mentioned it about the quality of reagents is a key thing, and people often they'll just buy something from a catalog and believe everything that the manufacturer says, and if it's a protein, they don't know what proportion of other contaminating protein there is. They don't know whether it's active or inactive. If it's a compound, they know that it might be pure to about 90%, but what does the other 10% do? And it's the inconsistencies and impurities and deviations associated with a lot of these biological reagents that lead folk astray in their work. And I think the second thing, certainly in my domain, is the belief that each new technology is going to solve the problems of the previous generation. So we had, for instance, people when they used to run assays back in the days, it was all done using radioactivity. And then there was a big move away from radioactivity for reasons particularly around the individual exposure, the environmental issues, the complexity associated with it. So, looking for a new drug then it involved using fluorescence. And then, they're involved using luminescence. Then somebody discovered that all of the compounds are nice and fluorescent themselves, and they also absorb light. So now people are looking to, let's go for a gold standard method. Let's use mass spectrometry, so we can actually measure directly the molecular weight of our product in an enzyme reaction, and we can do it directly. But actually, you find out that some things just don't fly in a mass spectrometry, and you miss them altogether. So you have this kind of belief that a technological solution moving forward will always give you, get you to some kind of truth. But in actual fact, it's the proper design of the critical path of experiments and the appropriate number of orthogonal readouts in different systems and different labs, which gives you, the best chance of coming up with a result that you can carry, which is sustainable, which others can repeat. So I think those two things, the reagents and how people view them, and the way technologies are implemented as being catch-all solutions, but in fact they're not. They just reveal a whole new set of issues that have to be dealt with as well.
That's a fascinating one. Indeed, one we see in biomedical science a lot. The latest readout, everybody wants to get their hands on it. The context of use is not necessarily well understood. And so you get a lot of publications out there which are highly impactful because people like to see what the new tech can do. That's, I think, an interesting one to continue tomorrow, to see how can, as I think all of the fields suffer from this, the one for the new toys. How can we approach that as a community, or as various communities? David, you have an opinion on your top two?
I think I would just emphasize a point that Raj has made a few times about the stigma or the barrier against null results or negative findings. There are many of those. When one is faced with one's own negative results, you often think, oh, shucks, it didn't work the way I expected to. If you're brave enough to submit that to a journal, reviewers or editors often say, oh, of course that was a null, you did it wrong, or there's obviously nothing going on here. Why would we publish that? There are methods for getting around that. It gets down to setting up the criteria for success before you see the final results. So create measures and controls that are orthogonal to the main research question, that demonstrate that the work was done comprehensively. And we've seen in clinical medicine and now in preclinical basic research that a pre-registration or peer review before results are known are effective at disseminating null results better than traditional methods, which are just shouting at people to share null findings or create a journal of null findings, which sometimes have trouble getting submissions, for example.
Thank you very much. Andreas, please.
No, essentially everything has said. My main points were also the things I would like to see some funding. So this is nothing to add, and at that point, thank you.
Okay, no problem. Thanks, Paco. Anything to add?
Well, I guess if I were to choose two troubles, let me say, well, one thing is the fact that the tools that we have, it's been said, instrumentation, but other things that we are to use for the research is getting more and more complex. And this means that often it is not accessible to the researcher, except if it comes together with a good user support. So we need to invest in that. We need to invest in an infrastructure and in a team that is capable of helping the user to get through their process without having to know all the little tiny details of the instrumentation. And this is linked to the quality of the instrumentation and the other things that I've been talking about. So I would stress that.
Mm-hmm. Clear, yes. So that multidisciplinarity, I think, is really, really important. Even in the basic research, I think we're starting to see the need for that. The people who know a term I like is everybody doing what they do best. So the technology who is the world leader in that machine and understands how to use it in that given biological context or whatever the research question is. I think that's a very important area where we need to stimulate better silos being broken down. I invite people to look at the chats. Johanna has mentioned about the microscopy community. However, I would like to first address Francesco's question earlier, which I think was a very good and very important question. So Francesco works for the biobanking infrastructure, and as a former patient advocacy representative, is very much about outcomes focus. And I liked that this question that Francesco made. He had recently tweeted about, the poor state of reproducibility, and he was, somebody gave him a sort of like a friendly admonishment saying, don't hang out dirty laundry out for people to tear us apart upon. What's the right thing to do here? I think that's a very important discussion, and one that we should not shy away from. So, Raj, maybe sort of, you're really at the forefront right now, also with things like anti-vaxxers and skepticism in general. What would you say? Is this a discussion we should hold behind doors, or should the public be aware?
The public has to be aware, I think, right? Because it goes back to what Paco said earlier, right? You want to influence society. In today's age of technology and media, the public are a key customer in all of that. That may not have been the case a few decades ago, but today, they are. So short answer is yes, public needs to be aware. But you do have a little bit of a challenge there, I think, that hasn't surfaced in this discussion, but it's food for thought. At another panel recently with the OECD, I brought this up and it triggered a lot of discussions. If you look at science, and all of you are researchers and scientists, and let's assume hypothetically the quality is good and you come up with evidence, okay? Because that's what science eventually gives you, data, evidence of something. What the nexus of where that meets the public, there is another key player here, politicians and policymakers. And when you looked at COVID, how science was translated, right, in terms of policy, there was a lot of discussions, in terms of how the outcomes of science was then translated by politicians for policy. Now, politicians represent society in many ways, allegedly. Again, I'm going to put a cautious word in there. Allegedly represent society. That is something I think as scientists that for me really came up to the forefront. Sometimes quality alone is not enough. It's about communication, right? And the engagement of non-scientists in the discussion, in where you want to land. And I think it plays to what Paco talked about earlier. Science cannot be a privilege of just a few anymore, of scientists. It needs to translate in a way that people can understand it, because very often people will say, what does this mean to me? And no matter which area of science you're working in, you need to ask that question. If it's not pertinent, great, you don't need to answer it. But if it is pertinent, you should consider it and apply it. So your uptake is a lot more successful. Over.
Thank you, Raj. I invite your opinions on that. Phil, how do you feel about that? Is this an internal or a public discussion?
I mean, it's, what is it? The political is personal or something. One of the most acute questions I've had in the last 6 weeks are from my parents who received the first round of the Pfizer vaccine, and they're asking, well, what's going to happen if I get the AstraZeneca vaccine in the second round, because I'm the son who got a job in science, and I honestly can't answer them, and I don't know anybody who can answer them. So it's Raj is absolutely right. There's a communication element, and I think there's on topics like that. I don't want to single that out in particular, but the communication hasn't been great, and at least the people who in my family who are thinking about knowing what they should do and whether they should, should I refuse to get this vaccine or that vaccine? And I can't answer that. And I think that, but it's sort of not my responsibility. I think that it's responsibility of others. The work's been done by the groups, and the risks associated and the ways forward should have been more clearly communicated.
Indeed. Yeah. Thank you. Andreas?
Well, I am pretty strict in seeing a lack of of communication, of research communication. So we do what we do in our in a way bubble, and it turned out that this is getting more and more difficult for us. So we live in a time. Well, many of us are used to the fact that the public does have some respect for research, for science, and that things are not so much questioned. But this changed in the last couple of years, and with each and every occurrence of difficulties, for instance, for vaccination and all these things, things get more and more difficult. And the only way we can react is to make our activities, our research more open. So open science is one of the issues, and explaining as much as possible what we are doing is the other thing. So for me, it's definitely necessary to have this discussion not only within the science community, but also outside of the science community.
Clear. I'm going to hold that discussion there. Sorry, Paco, sorry, David, but we have a very exciting new development from the chat. I'm going to ask Anne-Charlotte to intervene.
Yes, thank you, Anton. I just wanted to make a quick follow-up comment from what Raj and a few other of our panelists mentioned about the importance of communication. And I think it was also discussed in the chat earlier this afternoon about the importance of the wording and the narratives. When we're talking about negative results, of course, it may not sound like a very strong incentive to do so. So why do we even use the word negative results? And I think linked to that, to the broader discussion as well that we have today is every time you read about reproducibility, we talk about a crisis or a lack of reproducibility. So also there, I think just something to think about for all of us. How can we systematically in our communication also about the topic always keep a different narrative or positive narrative, so it's also better perceived by other stakeholders. I wanted to raise a question, a very interesting question that was asked by Werner Lusserli from DG RTD at the European Commission. So Werner mentioned that a lot of solutions and tools presented today reach very deep in the lab. So very specific practices well before results and data are produced. Earlier we mentioned what funders could do to best support them. We talked about funding, but what would be the other message for funders? Could they do more and other things than just provide funding?
I see David looking very, very active there.
I was just providing some in the chat there.
Oh yeah, super, thanks.
I think we have some specific recommendations for funders for how to properly incentivize or require these types of behaviors. One of the barriers that I hear a lot when talking with funders is sort of the question of compliance. You know, if we put out a new policy, how do we make sure that that's followed? And that's a real challenge, just because it's a worst case scenario, it becomes a big bureaucratic box checking exercise that wastes a lot of time. And so there are a lot of sort of creative solutions to make sure that the work is, the proposals or the work or previous work is best evaluated on the degree to which it was made openly available. Data were available, or replication studies were conducted, or work was pre-registered. Those are the types of criteria that we advocate be included in a lot of these tough calls.
Yeah. So I'm looking at the time. So Vina, I hope you can join tomorrow again as well, because we'll certainly continue this discussion, because I think also certainly in our experience at IATRIS, working directly with the funder can be very beneficial as well, to give some of those practical supports on how to structure their funding policy, even down to specific calls. So we definitely will bring this to tomorrow's discussion as well. But given the time, I'd like to invite any final burning comments from the panel. Otherwise, we'll bring it to a close. No? Okay, super. Thank you so much for your time. It was really fantastic, really interesting to see that we all suffer from the same slings and arrows of reproducibility. And I really hope that we as a community can continue this discussion and really find some practical ways to move forward also across the domains. So we're back together tomorrow, but I will hand over now to Anne-Charlotte to explain to us what tomorrow means. And I bid you all a good afternoon.
Thank you.
Thank you.
Yeah, thank you, everybody. Just very quickly, tomorrow we'll make a start at 9 o'clock. The session will run until 12:30, and once again, we have a very interesting lineup of speakers. some science, of course, from other disciplines, so other ERICs, and also a few representatives from funders and also research organizations that will join to give us another perspective on the topic. So we look forward to seeing you again tomorrow morning.
The UK Reproducibility Network. This has funding for 3 years. We have 1 year left before we end our current funding, and we're looking at ways to extend our work beyond that, because the growth in our activity and in our membership, as I'll talk about in a moment, has been really astonishing, and I think speaks to the appetite, the desire for some structure that can facilitate this kind of coordination. So our structure is that we have 3 different layers, effectively. We have local networks that are self-organizing groups of researchers at the grassroots, often led by early or mid-career researchers, who deliver activity at that grassroots level and act for advocates for change locally at their institutions. We also have institutions formally joining, and I'll give more details about that in a moment, where we have an institutional lead. The commitment that the university makes when joining UKRN is to create a role focused on academic research improvement, where that person will work at the senior management level of the university, effectively holding senior management's feet to the fire and advocating for changes to promotion policies, hiring policies, to create the incentives to drive the behaviours that we want to see at the grassroots. And those local leads and institutional leads are autonomous roles but work in partnership with, for example, the institutional lead acting as an advocate for the local network lead, who serves as a voice for that grassroots community. Then we have a stakeholder engagement group at the next level, if you like, which comprises funders, publishers, learning societies, other sectoral organisations. And the structure allows us to then coordinate activity horizontally and vertically. So, for example, we can coordinate activity across our local networks. We can coordinate activity across our institutions by, for example, adopting common statements on research transparency, responsible research evaluation, aligning our hiring and promotion practices so that the incentives created at one institution become incentives across a cluster of institutions and eventually the sector. And we can coordinate activity across our stakeholder group, and I'll give an example of that in a moment. But we can also work across those levels. So, for example, UKRI is setting up a research integrity committee, and they wanted to convene a focus group of early career researchers to talk about what the issues were seen to be at the grassroots level and in that part of the community. And so we were able to help UKRI, which is one of our supporters, to develop a focus group made up of our local network leads that then provided a direct voice for those early career researchers into the planning and strategy of UKRI. So we had our informal meeting in September 2018. Our launch was in March 2019. By December 2019, we had 10 institutional members. That's since doubled to almost 20. And we're about to have our 3rd annual meeting in March of this year. So you can see our local networks there distributed across the country, and we have about 50 of those local networks. Then we also have our institutional members, again, distributed across the country, and a range of institutions from the teaching intensive to the research intensive, from the large to the small, ranging from the Royal Veterinary College to University College London, for example. And the key thing here is that this is a peer-led consortium that is driven by researchers themselves at both the local network lead level and the institutional lead level, coordinated by a steering group that comprises myself, Alexandra Collins, Nicole Yance, Laura Fortunato, Malcolm MacLeod, and Chris Chambers, but which is very much meant to be an organisation that is for researchers and shaped by researchers. And our guiding principles are that we want to coordinate, work collaboratively, and not duplicate effort, but share effective practice across that network. And we want to be broad. Our critical mass, if you like, our centre of activity is around the life and biomedical sciences currently, but we're reaching out into the social sciences, into the physical sciences, and into the arts and humanities. And our supporters, our funders, if you like, include the Arts and Humanities Research Council and the Natural Environmental Sciences Research Council. So really quite broad representation in terms of disciplinary reach. So what does our activity look like? Well, at a local network level, we have a range of different activities that we promote, journal clubs, such as Reproducibility, for example, and when we were able to meet in person, we would send out materials to stimulate that activity at a local level, teapots and badges and so on. Science Club as a seminar series model. These are essentially franchise models. These ideas were developed by early career researchers. They still are owned by those early career researchers, but we support and promote them. And we're seeing rapid uptake of these different initiatives, not just across the UK, but internationally. This is the structure that we have at the University of Bristol, which is probably a little bit opaque because it's institutionally specific. But the point here is that this group that's been created with an academic lead for research improvement driving it brings together work on research improvement and research culture, links into and integrates across functions at the senior management level across the university, and again serves a similar coordination and alignment and harmonization function within an institution as UKRN attempts to do across the UK. And we're developing ways in which we can assess, this is Malcolm McLeod's work, measures of reporting quality, for example, that we can then use to benchmark our institutions. These are studies, rodent studies, preclinical studies, looking at measures that protect against bias from the ARRIVE guidelines, and effectively ranking institutions on the basis of how well they do these things or report these things, and as you can see at the bottom, the degree of change in these things over time, as a way of evaluating the performance of our partner institutions. So what we're trying to create is a cycle of research improvement that's demonstrated here, where various inputs identify what we think will be ways to improve research. And then we deliver training, modify our incentives, and deliver other interventions to shape behavior accordingly, but then review the impact of that on researcher behavior and on various dimensions of performance and output, and feed that back into the model. So that what we're trying to do is not identify a silver bullet solution that once delivered will fix all of the problems, because incentives evolve and behaviors evolve and the whole system is dynamic. What we want to do is create a culture whereby we are always evaluating ourselves and looking to see where the areas are that we might improve, so that we can enter this cycle of continuous improvement, both at an individual researcher level, in terms of that researcher's professional development, and at an institutional level, and at a sectoral level. In terms of the initiatives that we're promoting across different stakeholders, here we have an example of a partnership between a funder and a journal. So you've been talking about registered reports and pre-registration. These partnerships are between funders and journals because registered reports are in many ways similar to grant submissions in that what is reviewed is the importance of the research question and the robustness of the methodology. We know that there is a great deal of burden placed on researchers by demands to review grants and journals. In particular, journal submissions tend to go through several journals before they find a home and are reviewed repeatedly at each of those journals. With this partnership, what happens is that an applicant for funding submits their proposal to the funder. And if that proposal is given the green light for funding, the applicant is given the option to move it straight on to a journal that considers registered reports. And this is a pilot between Cancer Research UK and the journal Nicotine and Tobacco Research, which I edit. And then the reviewers who have reviewed the grant serve as reviewers for the journal. The efficiencies there are that they've already seen the grant, so they know what they're looking at. The protocol that's submitted to the journal has more detail typically than the grant submission. And because funding is so competitive, what we found is that grant reviewers often will not make any critical comments if they would like to see the grant funded. But when it gets to the journal review stage, they'll say, well, I loved your grant, but if you do this, then it will improve the quality of your eventual study and manuscript. And they can make slightly more critical comments at that stage without fear of it undermining the chances of the project being funded, so that the quality of the study protocol is improved before any data have been collected, and once that process is complete, the applicants have funding to do the work and in principle acceptance of the eventual study, and very little further review is needed apart from a stage 2 confirmatory check that that the protocol has been adhered to or any deviations have been described and justified, reducing the peer review burden over the life cycle of any given study. So we have these initiatives at the grassroots level, at the institutional level, and at the external stakeholder level. I've just given you some examples of each of those, but there are several others. These are our stakeholders, and you can see, if any of these logos are familiar to you, that we have a range of bodies that are part of our external stakeholder group, from funders, learned societies, other organisations like JISC that provides digital infrastructure to the sector in the UK, Research Libraries UK, the Association of Research Managers and Administrators, UK Research Integrity Office, a number of publishers. And we're looking to, again, coordinate and broker conversations across these groups, again, vertically and horizontally, using the structure that really, I think, is the strongest aspect of the reproducibility network. And because we've a relatively novel and distinctive structure that we think has the potential to be quite powerful, there's been interest in other countries around setting up similarly structured reproducibility networks. So in Europe, we now have reproducibility networks in Switzerland and Germany, and one is being established in Slovakia. More widely, we have another reproducibility network in Australia, and we're in conversations with other countries in Europe, in the Netherlands, in France, in Greece, to set up reproducibility networks. And one of the key things here is that by creating that community and by sharing materials that we develop, for example, we have a series of primers that we've developed on open research practices, we effectively can facilitate knowledge transfer across countries. And some of those countries, for example, Slovakia, that are developing a reproducibility network, can take advantage of the resources that we develop, despite being a country with a relatively small research and development budget compared to other countries. So this is a way of facilitating activity across a range of different countries, including ones that may not otherwise have the resources to do so. And the same logic applies at an institutional level as it does at a national level. So we think this is quite an exciting time. There's a great quote about revolutions, which is that revolutions happen very slowly and then all at once. And it feels like we are at the all at once stage now. Thank you.
Marcus, thanks very much. And that's a very optimistic view that you shared with us at the end. I really hope that is the case. And I think the fact that we had so many participants over the last couple of days already bears testimony to the growing interest in this. And I think the efforts at these grassroots levels that you describe are so important to that. I'm sure we're going to have lots of questions for you, and I do, but given the time, we'll take the next speaker, and we'll keep the questions for the panel at the end. So without any further ado, I'd like to invite to the floor Bonnie Wolf-Bernich, who's the head of research affairs at Science Europe, who is a member organization representing major public organizations that fund and perform research. So Bonnie is well permissioned to give us a lot of understanding of the work we've done there. Thanks a lot. Bonnie, the floor is yours.
Thank you. Good morning, everybody. Thank you to the organizer and the ESMO Forum for having me. Can you see my presentation?
Yes.
Yes, great. Again, thank you very much for having me. Organizers have asked me to present Science Europe projects. One was on research assessment, and the other is a project which will start as of this year on recognition in the research system. Okay. Just now I struggle to work. Okay, give control. Okay, perhaps I can do it now. Sorry, I just can't move my slide. Let me see again. PowerPoint slideshow. Okay, let me just see if it works. Okay, now it works. Okay. Very shortly, I would like to introduce your audience, Science Europe, which hasn't yet made acquainted with the organization. It's an association of major public research organizations in Europe. They are made up of research funding organizations and research performing organizations. We have currently 36 members from 27 countries. UKI, for example, is one of our members. Combined, our member organization spend 80 billion euro per year for research. So it's billions, not million, per year on research. And what is important to understand is it's a policy organization. There is no funding allocation involved, and also there is no operational role in the sense that managing EU projects. This is to keep independence from every stakeholder or the Commission, for example. We work on different policy files, for example, on cross-border cooperation, research data management plans, open access, research careers. So you see, we cover all important topics, also in the context of the focus topic here in this event. As I said, I will focus on research quality and assessment and the recognition system of research. But we do also active advocacy, everything which is linked to the Horizon Europe program, and also we deal with different types of EU regulation and legislation. So the importance of research assessment is for our members, which is the majority are from funding agencies, is not only a prime priority, it's a core activity. It's a responsibility of them to ensure and promote that the highest quality in research through research assessments are fulfilled. And when I talk about research assessments here today, I focus on grants allocation and on career pathways, less to evaluation of organizations, and for not confusing, peer review of publication journals are excluded in this study. So a high standard research assessment system needs, among others, it's just a short list, but for funders, it needs to capture the diversity of research outputs in a manner that is appropriate for each research field. It should promote good research practices, and reproducibility is one, and integrity, as we just heard from my president speaker. And it should reward excellent scientific contribution. And it would be an understatement to say that research assessment haven't shaped many aspects of the research landscape. They still use a huge influence on how research is performed and disseminated, and it falls under the topic of research culture. So if you want to change any policy to make changes in the way we assess research, we should understand the strength and the weaknesses of the research assessment on your national system, for example, and how robust the system is. If it holds the promise, is it fair, transparent, and very important, of course, eliminate biases.
So welcome back, everybody. I guess we can make a start again. Thank you very much for this, your attention this morning, and to the speakers. So far, it is going great. Now we will come to the concluding two speakers of the morning and then go into panel sessions. So first is going to be Kostas Klinos, who is joining us as the head of unit for open science at the European Commission. So that's Director General of Research and Innovation. Kostas, the floor is yours. Thanks for joining.
Thank you. I have 20 minutes, I think.
Correct. Yep, indeed.
Yep.
And if you use all the 20 minutes
up to yes,
for the talk, yeah, then we'll put the questions in the panel session. If you finish earlier, we can have a couple of questions also.
Okay, great. Thank you very much, and thank you for inviting me. So let me start by giving you an overview of the what we do for open science at the European Commission. Our definition is that open science is about sharing knowledge and tools, and this as early as possible, not only between researchers, which is probably the most common definition, but also between disciplines, which is far harder to do, but also between science and society at large. So we include notions such as science communications, citizen science, engaging with citizens in the operation of research programs and on the objective setting of research programs, the responsible research. All these are, we consider them as part of open science. Now, why do we do it? It's not an ideology. It's because we are convinced that it is, and we have seen the evidence, that improves the quality, the efficiency, and the innovativeness of research, but also it improves the trust between science and society. All of these are separate topics one could give a talk about. The Commission is in the good position to be a policymaker, in this case on open science, and at the same time a funder. A funder meaning that we can apply the policies that we preach into our own program. So we walk the talk and we experiment with the policies at the same time as developing them. And also we can have the money to invest where we think that capacities need to be built in terms of skills or in terms of infrastructures. Okay, just a parenthesis here to because everywhere one hears research quality or excellence, and personally, this is a personal note, I'm not so sure what it is. So, for instance, most funders, when they evaluate proposals, they look for novelty. They look to what extent the proposal goes beyond the state of the art. In Horizon Europe, or in the previous framework programs, we also look at the methodology. Is the methodology sound and so on? Is this what quality is or excellence is? Reproducibility. I mean, we heard the talks earlier on, or verifiability of the research. Should this be factored into the methodology and this be part of quality? And then quality and excellence, what's the relation? What's the relation between quality and impact? All these are open questions. Is research that, for example, looks at developing a new technology for vaccines, I mean, just to take a recent example, against contagious diseases, should be, by definition, be considered of having a higher appeal or be more excellent because they would have a higher potential impact. And then we struggled a lot about this issue of quality of outcomes, of potential outcomes, and versus the quality of the process itself and the methodology. I think, as I'll say later on, we have made our decision that the process, the research process, and the methodology of the research is an inextricable part of quality itself. What for sure is not quality is, and I saw the from Bonnie, the presentation from Science Europe earlier on, what for sure is not is the publication venue. It's not where you publish, it's what you publish. So what are we dealing with in open science? We are dealing, these are the practical things we're working on. We're dealing on open access. We're dealing on publications, but also data. We're working on fair data, on research data management, on achieving as early sharing of all research outputs as possible. And this does not include only data and publications, but and preprints, but also includes software or models or algorithms or whatever you can be considered an outcome of research. We are dealing with reproducibility, and which is related to all the previous ones, and this is something relatively recent, so for the last year and a half. And as I said at the beginning, the definition of open science, we're dealing also with societal engagement and responsibility. We are also dealing with those things that we consider enablers to achieve this improvement in the practice of research and innovation. Three things. One, and maybe the most important, but also where we have made least progress over the last several years. We had an entire talk about it from Science Europe, the issue of rewards and incentives or research assessment. Secondly, the issue of skills. And thirdly, the infrastructure, the technical infrastructure to be able to do all this, which we call the European Open Science Cloud, although this is kind of a misnomer because it's not a cloud in a technical sense, it's more the European Open Science Commons. A couple of words about the research assessment, and again, this was analyzed much more by the previous speaker, but basically we want to go from a system that today rewards competitiveness, rewards quantity with a publish or perish culture, rewards publication venue, to a system and does not reward open science practices and does not reward collaboration. Everybody is very hot on collaboration, but the system does not actually reward it, to a system that actually rewards collaboration, rewards sharing and as openly as possible, that rewards, evolves definitions of excellence to a more composite, a more accurate, more representative one, and incentivizes finally researchers to adopt the right behavior, and this is also connects to the reproducibility issue that I will discuss in a second. Sorry, where was it? Yeah. So the policy context for research assessment is that, I mean, as you know, there have been discussions for many years. There has been DORA. Practical implementation, though, from what I understand, is not extensive. In 2018, the Commission issued a recommendation on open science, and among the things that we recommended to member states and to research institutes is that they adjust the assessment of the researchers and research overall and the institutions to reward the culture of sharing knowledge. Similarly, in 2020, we had presented a report to the Competitiveness Council, and that includes a report on reforming the research assessment system. Very recently, so in September last year, we have also an action in the new policy for a reformed European research area. We have also an action number 9, to produce a plan to incentivize open science practices by improving the research assessment system. So we have a political background or the policy background there. The question is that how to make progress, or rather, because progress is being made, how to accelerate progress, because progress we think is too slow. So we feel confident of the level of principles, but not at how to approach the problem in practical sense and how to really affect progress. So this year, 2021, will be a year of debate. We'll have many consultations, both group consultations, bilateral consultations with many stakeholders, and we hope by the end of this year to reach agreement with the Commission on how to approach the issue, and eventually come to an agreement in next year between funders and the research performing organizations that are willing to do such reforms. This is I don't think this has been tried before. We have, of course, the Leiden Declaration or the DORA Declaration and others being signed by many research organizations. But here we start seeing the issue as an agreement between funders and between research performing organizations that as two parties that would agree how to reform the system. Today we see quite different discourses depending on whom you talk to. And for many institutions have a different discourse when they're talking to their funder, different discourse when they do the actual job of evaluating their researchers. Let me come to reproducibility now. As I said earlier, it is a topic that we started looking at seriously relatively recently. A year ago, a bit more than a year ago. We had a seminar in January last year, and we had various discussions. We came to a report that was published on the 1st of December last, and that is a scoping paper. So the scoping paper means that it is just a starter. It's not the end of the process, it's the start of the process. We say in this what we learned, why we think it's an important problem, and how we intend to move about it. The papers or the work, and there are many papers on reproducibility today that attracted our attention, are papers that argue that as much as 85% of funding in some areas is being wasted. And I have seen papers that argue between 30 and 85%, but it's huge percentages. Even if it's 30 as a lower bound, this is a huge amount of money. If you take health research, we spend 300 billion per year globally on this. So anything that can be done to increase the quality and the efficiency of this research, increasing its reproducibility, would be had a huge attraction. So if you look at the reasons in the literature of the lack of reproducibility, it is throughout the research process, from the definition of a research project or research question, which sometimes not pertinent, it's not relevant, it has been done before and people do not know, they don't take into account the evidence and so on, to poor study design. In many research areas, the inappropriate statistical expertise is very often a problem. The lack of proper collaboration, that there is people really stay their silos, although they're supposed to be working together, they don't really exchange information, to the results or the data not being fully accessible, because researchers, due to the award system today, to the research assessment system, are not motivated, are not incentivized to publish disappointing results, or are not incentivized to publish the data that did not lead to a new insight or a publication. Then we have the biased reporting of results. This was mentioned also extensively, very nicely by Marcus earlier on, that with selective reporting, with all kinds of cognitive biases and confirmation biases and so on. And then finally, we have research reports that you cannot verify or reproduce because the methods are not fully described, or because the software is not made available, and so on. And this is my colleagues in the unit show this IKEA compendium, as it's being called, as an analogy for the reproducibility problem, that making a table or a couch or whatever from IKEA is supposed to be straightforward. You follow the methodology, but then you realize along the way that something is missing, like a piece, for example, and then a small piece may be missing, but then you cannot finish the job. So what we have learned? We have learned that there's a clear evidence that there is a lack of reproducibility in many disciplines. It's a real problem. We don't like the, we would propose that we're not talking about the reproducibility crisis because it undermines public trust in science. And we should more look at reproducibility as an ideal to which we tend, but we know that we'll never reach. And sometimes there can be very good reasons. I said all of the bad reasons for the lack of reproducibility, but there may be good reasons also. We realize that reproducibility has to be tackled by tackling the full spectrum of practices, from the conception of a research project to the publication of these results. That the main drivers of lack of reproducibility is research assessment and the research culture that's associated with this. So again, the publish or perish attitude, again, on this, I think Marcus made an excellent presentation earlier on, so I don't need, I think, to explain more. Regarding this, we see it also as part of open science, in the sense that the old logic of open science, in other words, open access, that we try to make open the results, the final outcomes of research, we have changed it now. And we are looking at opening the entire process, not just the final outcomes, for example, the paper. But we're looking at the whole process, and we realize that in addition to openness, the associated concepts of transparency and integrity are also key regulating principles. Again, Marcus talked a lot about the integrity, so I'm not going to say anything more. If we tackle the problem at the end, at the publication stage, it is certainly too late. And finally, we also realized, as I said earlier, that we need to do this together with all the parties. It's not about scientists. It's even more about the culture in scientific institutions, so their employers, and what do the employers, these institutions, what kind of behavior they reward. It's also about, and very much about, funders. funding this research. It's about publishers, and of course, it's about research infrastructures. Indirectly, I said I talked about this already. So what goes wrong? Why it goes wrong? It is again academic sense and rewards. It is the whole grant system, is the research culture. There is an issue, let's say, of generational dynamics. In other words, I have seen in our discussions and the consultations that the younger generation of scientists are very open to a reform of the system. However, they are concerned that however, the rules are made by the more senior scientists that have grown in the old quote-unquote system, and the young scientists are very concerned of the perception of the more senior scientists regarding their approaches to research quality and reproducibility. What also goes wrong is infrastructure or lack of infrastructure. This our action in the Commission to try to correct this is this EOSC, European Open Science Commons initiative, and skills, including for statistics, including for research integrity, and including for data of all sorts, data and the both the education, the training of individual scientists, as well as the making data skills, data expertise available at institutional level, the so-called data stewards, for example. So what we can do, what we're thinking about, at least, is one policy approach or one policy, and I'm almost there, is to be able to, as a funder, to nudge the research process to provide incentives towards thinking about the methodology and about the research process in its entirety, motivating the right behaviors. We already do data management plans as an obligation in the new program, Horizon Europe, co-checking. We provide early sharing. We have this as a article also in our contracts now for our grant holders in the next framework program, Horizon Europe. Registered reports is another example where you force people to think about the methodology and put it down upfront so that you can avoid the confirmation biases or other types of biases later on. Issuing guidelines, which is we did for COVID-19. Different type of action is find best practices, diffuse them, cultivate them, and so on. We are looking also at extended notions of integrity, again, along the lines that Marcus presented earlier. As I said at the beginning, we only started with the study on reproducibility. We only started with the scoping report that you have seen, but we are now carrying out a study on reproducibility in Horizon 2020 projects. So we want to see to what extent we can replicate, if you want, the recommendations we have had till now within our own program. We are now finalizing the Horizon Europe rules and procedures, and there we have taken into account strongly all aspects that I showed earlier on related to reproducibility, including about fairness of data, openness, but also have now a term in the contract whereby for verification purposes or reproducibility purposes, even if data have to be kept closed for legitimate reasons, which is often the case, somebody who wants to evaluate or verify the research can ask for the data to be made available to this person only, and the people who collect it or use the data have to comply, have to make the data available. So I stop there. Then my next part that I didn't talk about is 2 or 3 slides is about what are we doing within Horizon Europe in terms of taking into account open science policy and reproducibility for the program that will start as of April or May this year. Thank you.
Thank you, Kostas. Really interesting talk, and really wonderful to see that the Commission, obviously, who has such a lot of influence among funders and policymakers, is really taking this to task and really formulating a coherent long-term strategy to support the field in this. Wonderful talk. We will take questions, I think, during the panel session. We already have quite a few very good questions in the chat. So I'll now hand over to Andreas, and Kostas will welcome you back in 20 minutes. Thank you. Andreas Scherer of the Finnish Institute for Molecular Medicine, which is an EATRIS member institute, and Andreas also acts as the chair of the EATRIS Quality Initiative and has been for many years and really has helped us drive some bottom-up initiatives around quality and reproducibility. Andreas, please take it away. Thank you.
Okay, thank you very much. I hope you can hear me well. It's a really I enjoyed this meeting very much so far, and it's great to be in the lineup with such great speakers. It's a true honor. So Anton and Ann-Charlotte asked me to give an introduction into the importance of data quality and reproducibility in biomedical sciences, and especially in translational research. So let's get right into this. So translational research may be described as the scientific processes that move basic research findings into the clinical settings. And only once we have generated a solid evidence-based hypothesis on the relevance of the initial findings, we should move further in the process and go into the preclinical setting and using animal experiments. And any progress, I think, into preclinical animal research without relevant and sound information would be highly unethical. And then once we gain information from animal studies, we show the potential for health benefits, we can then move further through various phases of the translational and clinical path towards clinical application. Any failure, I think, to obtain sufficient data from a step in this pipeline before moving ahead will be unethical and costly at a later phase. And since the entire process is very costly and time-consuming, as we have heard before, we should first thoroughly validate the by performing the experiment and some background.
Sorry, just a reminder to all non-speakers, please mute your microphones.
Thank you. So we should first thoroughly validate the initial findings by performing the experiments and analysis again, and then under slightly changed conditions to see whether we can repeatedly get to the same hypothesis and only then move forward. So overall, the goal has to be to find the best treatment for each person, for which the term personalized medicine was coined. So here you see an illustration of the more traditional way of developing drugs, the so-called one-size-fits-all principle, where a patient group, let's say with a certain type of cancer, could be grouped into maybe 3 risk groups, let's say. And each group receives the same drug, each person receives the same drug, and maybe though in different doses. And since too little is known about the nature of the tumor, the drug may not show the desired effect in each case, and leaving some patients without benefit, others with adverse side effects even, and only a small group might benefit from the treatment. So often the reason was not known. And experience and meta-analysis in a number of diseases have shown that the substantial group of patients do not benefit at all from treatment. And staying within the oncology setting, as you can see here on the far right, only 25% of patients benefited from treatment, as shown in this early analysis from 2001. So of course, this is the older approach, when nothing really in detail was known about cancer subtypes also. And since those days, a lot has happened. And for example, take the genome sequencing alone as an example, with the human genome sequence being published in 2001, and then the full sequence in 2003. So with all the progress made in analytical technologies and informatics, and millions of human genomes have been sequenced now, and other molecules can be measured in large-scale fashion, in very small scale apparatuses, if you think about it, in labs and hospitals on the benchtop. So giving all of those technologies and improvements and advancements, they give you a profile of a person's genes and proteins and many more features within a day, a few days, or only a few weeks, and depending on the technology, of course. And this has led to the field of personalized medicine, as we now know, staying in the staying in the area of oncology. That tumors evolve and they are composed of subset of cells with different features, possibly including lifestyle and other factors can contribute as well to the evolvement of a tumor and the health of a person. And so accounting for some of these discrepancies, we have seen in the treatment efficacy. So personalized medicine can now take advantage of the technological advancements in the most recent decades to optimize the timing and the targeting of interventions for maximal therapeutic benefit. And there are three key elements to precision element. One is the stratification by risk, the detection of pathophysiological processes as early as possible, and preferably before clinical presentation, and the alignment of mechanism of action of interventions with an individual's molecular drivers of disease. And as you can see on this slide, and as I touched on earlier, personalized medicine can build on growing experience with existing and novel technologies and analytical methods. But of course, each technology comes then with its own challenges and that need to be addressed. And I remember the days when scientists started using microarrays for gene expression measurement. And in the beginning, the hype was immense, and tons of papers on medical discoveries were published, where people used microarrays to try to explain phenotypes. And only after some years, actually, questions on the correct use of microarrays in larger studies were posed. And so to address these technical and analytical challenges, for example, consortia were formed because it became soon very clear that single laboratories cannot tackle the issues of quality and guideline development, let's say. So only consortia could do that. So for example, the US FDA guided microarray quality control consortium, MACQC, that I had the pleasure of working with, and now we're in the sequencing quality control phase, actually. So meanwhile, technical and analytical challenges which affect the data quality and reproducibility have been identified and in almost every technology that can be applied to personalized medicine. And the issues have been found in the bioinformatics sector, study design, lack of standards, and we've heard so much already about this during the past 2 days. So there are a number of definitions of reproducibility in the public design domain, and from my part, personally, I favor this one here, which has been published by Ioannidis' group, which stratifies the issues into 3 domains: the methods, results, and inferential reproducibility. And the methods reproducibility is achieved when methods, computational code, and materials are reported in a transparent fashion so that the procedures can be repeated. And ideally, this is the prerequisite for achieving result reproducibility, whereby result reproducibility has to be, of course, defined prior to the reproducible study, so that your reproducibility study, so that you know what is your level of reproducibility that you want to achieve, the minimum level. So essentially, results reproducibility means that you obtain results from an independent study that are as close as possible to the results of the original study, whatever as close as possible means, but one should define this before you do the studies, in my opinion. So for us, of course, one cannot always expect the exact same results, but if independent studies lead to the same conclusion, inferential reproducibility is achieved. So what are the factors influencing reproducibility? And I'm sorry if there's a lot of redundancy now with previous speakers that have done this, have done their own research and surveys around this. But here are 2 papers that I think also may contribute to the discussion quite well. In 2015, the Global Biological Standards Institute, GBSI, under the leadership of Leonard Friedman, who we worked with a lot within IATRIS as well, he published a widely cited paper where the most important factors contributing to irreproducibility were identified based on self-assessment of scientists at different levels of their career. And the most important factor was non-transparent and incomplete reporting. And the next 4 factors that you can see on the left graph there, the next 4 factors are in the area of experiment design and analysis, and then again, incomplete selective reporting. And also reporting bias was one of the most important factors in the questionnaire published by Nature, immediately followed by pressure to publish, as we have also heard before, the publish or perish system. In another white paper by the GBSI, also headed by Leonard Friedman, Friedman's team also discussed that academic research widely lacks a formal quality system, unlike industry, for example, which is of course much closer to the clinical setting in the drug development pipeline, and thus has a much stricter regulation in terms of execution of experiments and reporting within the company, but also to authorities and the public. And I think EQUIPT and PAASP can play a very important role in developing such a quality system within the academics as well. And we are in touch with them as well, and our IATRIS is a stakeholder there. So the low level of reproducible publications can be detected across biomedical disciplines, as these meta-analysis here in this publication from Begley and Ioannidis show. The reasons for concern of data quality in publications reach from small number of samples based on which hypotheses are grounded, to other statistical issues, publications of artifacts, false positives or negatives, pre-analytical quality of samples. So we've heard this many times now over the past 2 days, and of course in biomedical sciences, we are not an exception. But why is this at all relevant in biomedical and translational research? Well, as I've shown you in the first slide, translational science is a continuum, so which starts from discovery, academic or industry research, which is then developed by industry into clinical applications with or without academia. So the data and the reporting quality which is generated at the very beginning has a huge impact on the success at later stages after many further years of research based on the initial finding. And many millions of dollars or euro, what have you, have been spent. So this has also been noted by the GBSI in 2015, and this highly quoted graph that about 50% of biomedical research output in the US alone is not reproducible, accounting for a loss of public funding of about $28 billion US, most of which are spent on reagents. And we've heard before that by Kostas that the estimate is going to 85%. So it becomes an issue of for funding organizations and for industry, which just does not know anymore which results to trust. And therefore, so how do you pick the relevant data from publications, for example, based on which you further develop your compounds? So therefore, close collaborations between industry and academia is needed so that each of those partners clarifies the expectations and knows what is required and what can be achieved. So how can we address these issues? So when it comes to the investigators, I think that there are at least 3 levels, and maybe simplifying this quite a bit. But let's stick to 3 levels. When it comes to the investigators, one should always apply rigor to your own data, and we've heard this before already from the European Commission side. Develop an analysis plan in a team prior to the experiment, report thoroughly and obtain training and understanding of research practice. And I've tried to develop a schematic which highlights some of the key factors which positively affect reproducibility and traceability of research data along the main steps of an experiment. And unfortunately, we don't have really time to discuss this in detail, but when you get the slides and have time and interest to look into this more, you will see that each step here has elements of standards, validation, which we haven't really talked about much in the past days. although there were some mentions yesterday about the quality of materials and coming from vendors, for example, so quality of antibodies, cell lines, and so on. We certainly need to touch on that. So standards is very important. Validation, team formation, together people with expertise in the fields needed at each step. Since you just cannot be expert in everything. So, but the most important factor certainly is transparency and data sharing, practical availability to enable reuse of information. And there are many organizations now that work on creating efficient systems, as we have heard before, supporting data and information sharing, but this is not really now my topic here, but if you're interested, please go into a website listed here. For example, as what we have heard before again, the European Open Science Commons, as I've learned, of which EATRIS is also a member and works closely with them, and other ERICs on the call, like BBMRI, and then of course also there's Elixir working with EOS. Or then take a look at the Galaxy project, for example, which is largely run by Elixir ERIC as well, which is a specialized tool for data analysis, providing workflows and data repositories. So all great, and then of course the Center for Open Science that was also mentioned yesterday. So EATRIS is particularly useful in supporting investigators. As we consist of now 100 academic research facilities across 13 member states in Europe, and we have a large pool of expertise on quality standards in developing practical guidelines and harmonized technological processes. And we also are helpful in multi-site comparative study design and execution. And then in response to growing concerns on the low reproducibility in biomedical sciences in 2015, we formed the EATRIS Quality Initiative that I'm chairing. And it's an umbrella term for EATRIS participation in international consortia with the goal to establish processes and guidelines and technologies that I've listed here. And this will be now my third last slide. I hope I still have a couple of minutes. So not only investigators, of course, have a responsibility towards data quality, as we have learned also before. Publishers, editors, and reviewers play an essential role, and maybe I can go over this fairly quickly because we have talked about this in extenso before. Requiring transparency in reporting, pre-registration is an important factor that we can look at even more, and encourage pre-publication for public peer review before final publication. Funders have another important role. They hand out the money, so therefore they can play a very instrumental role in improving reproducibility. They can demand sufficient information on how the applicant intends to ensure data quality standards. They can fund confirmation studies on organizations that are supporting reproducibility studies. And moreover, I think as reproducing studies takes a lot of time, they should consider longer lasting funding periods. And so this is my second last slide before I log out. There's a couple of thoughts still that came up yesterday during the first day to me. That was reproducibility of an experiment should never automatically imply that the experiment was well conducted. So also bad experiments can be reproduced or replicated. So just by sharing bad data and bad protocols, of course you can reproduce the experiment, but that doesn't mean that the result is valid. So we should go away from the reproducible is high quality. And not being able to replicate an experiment should never automatically lend more credibility to the second experiment. The fault can be within the second experiment that failed to replicate the first one, as also is being discussed in about these two papers that were mentioned in the talk before, which led to the assumption that 85% of research is not reproducible because the group that tried to reproduce the first experiment used actually the wrong formulation. So they didn't build on the information they received from the first study group, but then they claimed afterwards that the study was not reproducible. So we have to be careful as to who replicates an experiment and with which tools. So we have to look at both. But just saying, an experiment is not reproducible, it doesn't mean the first one is not valid. And I think, coming to an end, I think it's very important that we need training in scientific conduct. How do I perform an experiment? And many researchers, I've never heard about this really when I was doing my thesis and everything. It was like, okay, here's a question, work on it and do it. But I think I would have even more benefited by studying beforehand. How do I generate a hypothesis? What do I have what information do I have to collect to make an hypothesis? I need training in experiment design, which is extremely important. What are the best samples? How do I collect them? How do I treat the samples? What are proper controls? Do I have the skills? If not, where do I get them? And how do I evaluate my results? What does a p-value imply, and so on? And I think these are important training aspects that researchers need. And we don't have to go as far back in time as this little guy here who says, I want to go biking with Andrew. I submitted all the right forms, added Dad to the collaboration, and had Billy audit my plans. All I need is your electronic approval. I don't think we need that to go that far with the training, but it's good to make students aware of these issues. So thank you very much. Sorry if I went over my time here.
No problem, Andreas. Thank you very much. Very interesting final talk, and I think very nicely cross-disciplinary in the sense that it's really about the reproducibility issue across domains. Thank you very much to all speakers. Nice to see the different viewpoints, but I think there's also a lot of agreements on a lot of the main issues, which is very helpful for us to read some conclusions. So I am now looking to all the speakers to come and rejoin the panel. Is Anton Bespalov on the call? If not, Bjorn, are you coming in for PASP? Okay, we assume that nobody from PASP is available. That's not a problem at all.
Sorry, I'm here. I could come in. Yeah.
Please do. Yes, if you have time, that's great. Thanks, Bjorn. Yep. Much appreciated. And I'd like to also welcome a new speaker to the panel session today, who's Anne-Marie Correa, who you see on your screen, and she is head of UK and Europe research landscape at the Wellcome Trust. Welcome, Anne-Marie. I think we'd be very excited to also hear your viewpoints today. So there were lots of interesting questions in the chat, which obviously I've now completely lost. So I look to Anne-Charlotte to help us with some questions. Anne-Charlotte, would you like to kick off the questioning, or shall I kick off?
Yeah, I'm happy to kick off with an interesting question that was asked by Daria. How do you marry open science, sharing, and sustainability? Within Horizon Europe, the concept of progressive way out from EC funding is very important. On one hand, projects are asked to ensure their business plan sustainability, and on the other hand, guarantee open access to their results, tools, etc. How can we ensure that both are respected?
That's a great question. I think, yeah, Kostas, I think
you want me to respond, I guess.
Yes.
Yeah, it's a good question. I mean, our guideline for data openness, as well as for all the other digital outputs like software and models, is that as open as possible, as closed as necessary. So it means that the default is open, but if you have legitimate reasons to close it because you are taking a patent, because you want to there will be a spin-off company to take advantage of the results, to use the results or something like this, it is legitimate to close it. The question, the main issue here is that the default is open. Then I know that many funders, or a few funders that I have been talking to, are a bit concerned that we have quite some public research or some academics, some researchers are very quick to protect results and not quick enough to share. In other words, that they have the default as protection, just in case, without necessarily very concrete plans or, but, protect it. It's a patent. It looks like it might be used one day. And then we end up, and this is, I think, I have no intimate knowledge about this. We have not done a study, but I get the impression that this is very variable according to the institution, to the country. But that, yeah, I think this is not healthy. In other words, if it is the default becomes protected just in case, and then secondary thought sharing is not good. But certainly you can protect it, you can close it if you have good reasons. And one of the good reasons is that you want some again to create a company to something like that, to have a business development plan. I don't think it's very useful to bring these two things in contradiction, though. In other words, because I have heard it quite a few times recently, that you know, giving the impression that openness contradicts exploitation, and this is not true. This is not true, as we are very well known from. Yeah, maybe it's not the place now to expand on this, but this is not true at all. On the contrary, I think we have evidence that openness, on the whole, for society or for the economy as a whole, greatly accelerates exploitation.
Thank you, Kostas. Anybody wish to add to that discussion, or shall we move to the next question? Okay, great. And Charlotte, something from yourself, or shall I chime in?
Can
Yes,
I make
please
a comment?
Sure. Bonnie, go ahead. Yeah.
Yeah, sorry. I'm now joined in via telephone. Yeah, okay, it is in life is life. Regarding openness or open science, I think as we discussed, I mean, it's a thing. It's a research culture. It's how you have been grown up, and a competitive edge is, of course, if you have a strategic advantage about your research results. And I think early career scientists are much more open to share, and I think this is part where a research culture has to be changed, and where you have to put the right rewards and incentives, that you incentivize this behavior. That might be in the future on expense of more publications, so you would potentially publish less, but you would show a certain behavior which need then to be rewarded accordingly. Thank you.
Thanks very much, Bonnie. Very clear. That's an interesting question. I'd like to actually depart from that point. Perhaps publishing less. So. Could the statement that the sort of mass production industrialization of scientific output is commoditizing it and is at the expense of necessary quality? Are we allowing studies to be underpowered because they're not using enough, for instance, enough resources to power up the specific study, because we're funding more research for cheaper? Is there an argument to say maybe we should be funding less research that's more robust? So more money on not the lab process, but also the peripheral quality and impact related elements around it, so that the researcher does take more time to make sure the team's multidisciplinary, has more sticks and carrots around ensuring reproducibility and replication before publication. For instance, I'd like to hear your views on this. Is the fundamental approach in need of repair? I'm going to put that first to Anne-Marie, who's Wellcome Trust obviously has spent a lot of time, I think, on questions like these.
Thank you very much, Anton. So, I mean, as a research funder, when we look at applications that come in, we really do pay an enormous amount of attention to the power of the study, the design, etc. Do we get it right all the time? No, of course we don't. I think your point about the peripherals is a really important one, and I wouldn't put them as peripherals. I think this is where the culture that Bonnie referred to is fundamentally important. We need to totally shift the way that we think about things from not just the what, but the how. And this is the fundamental core that comes across the Wellcome's sort of work on research culture, where we've really been advocating to try and get that much more sort of on the agenda. And I can't remember who said, but it feels like we're in a really sort of pivotal, I might even be Marcus, we're at a pivotal point at the moment where, you know, the momentum is gathering so much. So what do I think we ought to be doing? I think the things we ought to be looking at is how do we make it easy for people to do the right thing even when no one's watching. And that's very much about how we set up our panels, how we review. It's very much about what we put our money towards. How do we enable people to have persistent identifiers on all sorts of things that matter? How do we ask the right questions about, what people have done? How do we draw attention to things like the importance of leadership? And how do we pay for things that we value? Somebody talked about data management plans. Great. Okay, so when we do the review, we're just experimenting at the moment through the work that Robert Kiley's doing in saying we won't decline an application if the data management plan isn't completely right. We'll actually put some money in and we'll work with people to get it to the position that we think is correct. So how do we really, put ourselves at the centre of this as well and say, how do we make it easier for people to do the right thing? And how do we know whether we're doing the right thing as well? This is where the whole question of research on research comes in.
Thank you. It's a good question indeed. I think what's wonderful is that there's this level of reflection at all the levels now, having seen the bottom-up approaches that Marcus was describing, the efforts of PASP, et cetera, et cetera. Björn, maybe you could tell us a little bit about that, so all of these, the work that's been put into these accreditation systems. Is this an onerous drag on central budgets? How would it, would it change? Would the infrastructure managers that would adopt these standards feel a difficulty in applying them because of cost and time and drag?
So it's a very important discussion, and it's, of course, I mean, quality costs a bit time. There's no question about that. However, I think it's a cost we really need to invest. And that's what we tried to do with the equipped quality system, to actually minimize that, to minimize the effort that researchers need to put into the system so that the costs are kept low. But we have the good outcome that data are transparent and that that the experiments can be repeated. So that's what we really try to do with the equipped quality system, and then also building in this feedback loop. I think it's important to have data management plans, and we have also discussed it with German funding organizations who request that. But in the end, do you actually know that the data management plans are followed? And I think that is a big issue in this whole system. The only real feedback loop we have is the peer review. But there is no real feedback on any other level. And I think that could be improved. And that's a little Schräubchen, a little, something we need to tear on. So to bring in another level of feedback.
Yeah. And that's actually an interesting segue to the next subject I think that we touched upon yesterday, multidisciplinarity in the research process. We're doing such complex research right now. A biologist is not a drug developer, is not a biochemist, is not an imager, cannot operate a cryo-electron microscopy machine and get it right. So how can we encourage and even enforce multidisciplinarity, both not only in the execution stage, but in the design stage? We work with a lot of applied research, and funders are sometimes asking biologists to become drug developers. But don't enable access to the sorts of expertise you need to really do a development plan that's about going towards clinic. So how can we as a community provide tools and support to also enable multidisciplinarity? I'm open to volunteers from this on anybody who knows of initiatives or ways to do this. It's a tough subject.
I mean, if I may start from my experience at our institute, we are very closely located to the Helsinki area hospital and so on, working also closely with drug development companies. So I think from our perspective, I don't see that really as a major hurdle because there are interactions already between clinical sample providers, let's say, and I think in some instances it might be an issue if you're really working isolated in an isolated fashion and you don't really know anyone around. And I think in that aspect, I think, for example, infrastructures like IATRIS are very useful because we have a whole list of expertise and knowledge and where to find people and so on. I think that's where we are very where we can be very useful. I hear this a lot though when I talk to people that, oh well, I know where to go, so don't worry, I know my friends, and it doesn't seem to be a big issue actually in my experience. But I think a collection of expertise, where to find technologies, where to find the experts that run certain machines, where to find people that know something about data management and so on. I think that's a great that's a great incentive also for funders, so that they can point to can help people try to find the expertise and so on. So
indeed.
I don't know how others see that.
Super. Anne-Marie, please go ahead.
Yeah, I was just going to add to that, because I think this question about multidisciplinarity is obviously one of these things that is sort of been around for a long time, and I think it's even more important. And if we think about just the lessons that we're learning from the current pandemic, multidisciplinarity means many different things. And I think here's where actually we've got to start setting the culture in a way. We do have this system, as Marcus outlined, that sort of hero worships the sole PI, the researcher who gets all the stripes on their shoulder and all the applications and the grants and the papers. Really what we've got to start looking at is actually, how do we know that the questions that are framed in a way that are pertinent to the environment in which they're going to be implemented or useful to? And we don't generally tend to ask questions like that very well when we look at applications. We do when we have, big strategic initiatives. But if you think about the fundamental importance of, the social context, the political context in which a lot of these things are working, we've got to start asking wider, broader questions. We've got to start normalizing the fact that, it is actually not good science or not good research to be not asking those questions before you frame your application. And I think there's something really quite fundamental in that. So it's not saying, you should know everything. It's good grief, there is no possible way you can. And, how do we shift this? So I think it's a practical question about discourse. It's a practical question about how we work as funders. And it's a really practical question about how we look at impact. And we tend as funders to look at impact at the end of your grant. That's not really helpful. If you look at some of the great work that Research Fish is doing, looking at sort of how if you track an impact back 20-25 years, you can see it's 4 or 5 different funders, it's 3 or 4 different groups, it's half a dozen institutions that leads to that point. We've got to start telling a better story.
Yeah, very nice. I'm going to give the floor in a second to Volker, and then right after that, Anne-Charlotte, if you could bring up that question of Jenny, because that links very nicely to Anne-Marie's discussion about impact and wider society. Volker, go ahead.
Yeah, I just want to say from our side, this issue with multiple disciplines is, I think we don't see it as such a big issue, because from our side, we have got obviously geologists working together with chemists, working together with engineers, and typically if they conduct some research together, for example, a chemist goes to a geological facility, they have got the scientists, the experts working at that geological facility to support the chemist or the engineer with any issues they might have. So they're working together on that level quite well.
Super. Yeah, nice to hear. Good to hear that it is solved in the field there, so it's not an issue for yourselves. If you could get a question about that came from Jenny, please, Anne-Charlotte.
Yeah, sure. So Jenny mentioned that the conference is particularly timely because of also issues relating to COVID. And Jenny says that she sees in reviews that she's done as a lay expert for some UK funders that a hypothesis can be skewed when a researcher relies and includes, as he or she rightfully must include patient input into a proposal. But the patients that are consulted suggest, without either fully understanding the existing landscape of work being done or being fully representative of all the community that they're supposed to represent. How can this type of bias be eliminated?
It's a very good question. So this is, it's in the life sciences field. There is an increasing trend of involving the patient in the research question, which it's a wonderful trend. But a lot of people, ourselves included, don't know how to use it optimally and how to treat it with the respect, but also the utility that it is. Love to hear from anybody who has experience of this and can give us some feedback. Anne-Marie, please go ahead.
At the risk of being noisy, it's a really important question, and I think the issue that I would highlight here is it's so crucial not to be tokenistic, as Jenny points out. And just because you put it on a form and you ask somebody to tick a box doesn't mean it's being done in the right way. And I think that's really a lesson we have to take to heart. One of the things that we're doing at Wellcome is exploring, the use of advisory groups, of networks, of people with lived experience. So, you will always bring your own personal experience to something. You need a wider forum in which you can, have discussions and shape and co-create the research. And I think this is the really important thing to think about, is how do we enable that type of activity to take place so that you're not just, giving yourself a false sense of security that the box has been ticked and off it goes. So I think Jenny's point is a really important one, and the short answer is it's not going to be straightforward to do, but in the sort of spirit of being a research funder, what we should be doing is trying things, putting a research framework around that, feeding back how that's working and improving the system as we go.
Sounds sage advice. Thank you. A very good comment from Daria Jukovska, who's the coordinator of the European Joint Program in Rare Diseases, a very large multi-stakeholder initiative. It's important to train patients, and it's a very good point. So I think this is definitely happening under that joint program, but also there's an organization called EUPATI that actually does train patient experts. Very interesting initiative, and potentially one that could be one of reference. Jenny, if you'd like more information on EUPATI, do please feel free to put it into the chat or contact us afterwards. Any questions, Anne-Charlotte, that you'd like to bring in? Otherwise,
I think an interesting question related to the topic earlier. So do some EU funding programs, so I think any other funding programs, as a matter of fact, take into account the track record of researchers on open science or robustness measures when evaluating proposals?
Yeah, I can take that. We went through a discussion that lasted more than a year. It was impressive within the Commission and then with our member states in order to change the system from evaluating open science aspects as part of the impact criteria. We have three criteria: impact, excellence, and implementation management. So some open science aspects have been evaluated in the past as part of impact. The idea is what I said in my speech, that if it helps disseminate results better, therefore you increase the impact. But because of all the things we have been discussing, we want to change this mentality and to say that open science starts from the beginning of the conception of a proposal. It is part of excellence. So open science is good science. It is, of course, it's also that increases the impact, but so you can have it everywhere. But given the choice between where to put it, we would, if you have to address it only in one of the criteria, we would address it in excellence. And this is what I described is the final conclusion, which it took many discussions and meetings both within and outside the Commission, because it's very difficult to change this mindset. That okay, they want open, okay, I will have open access. It's something that you do at the end. Whereas the idea is not something you do at the end, that at the end you have a publication or data set and you open it up. It is what you do throughout the process that counts. And it's really hard to change this mentality. So in answer to the question, yes, we do take it into account in our evaluation criteria. And in the also regarding the track record proposers. No, with this we don't at least not consistently. Depends on the reviewer, but we don't ask that the proposers have specific track records on open science. Maybe this will come in the future. It will be a further incentive to towards open science.
Thank you, Kostas. This is a question for you, Marcus. The UK Reproducibility Network is beautiful in how bottom up it is. Who are the catalysts within the organizations? Is this the researcher themselves, or is this is there a specific phenotype that looks at this and says, "Wow"? Or is it yeah, I don't know. You tell us. You're on mute.
Sorry, a year and I still haven't learned. It's at all levels. So what we have, I guess, is a community of people who are just very engaged with and very passionate about these issues. But there are those people, you know, Anne-Marie and Wellcome, for example, is one of those, and the Wellcome works very closely with us. But then we have them at the grassroots as well, in terms of early career researchers, mid-career researchers, senior researchers who are the institutional leads and advocates at that level. So you need agents for change, and you need to link those agents together, because this is effectively a collective action problem. And if we work collectively, we can drive that change, because the culture that underpins much of this, and Anne-Marie spoke to this, is embedded in ourselves and our institutions and our ways of working. And if we all collectively chose to work in a different way, things would change very rapidly. But the inertia that a culture brings with it makes that change difficult. And what Kostas was just saying, I think, reflects the kind of interconnected nature of the problem. We want to incentivize and promote open research practices. But how do we do that? Well, funders can mandate, or they can incentivize by recognizing, for example, as some funders certainly in the UK do, preprints as well as final publications as a move towards recognizing that. They could go further. One of the advantages of open research is that researchers can generate a number of more granular tangible outputs with DOIs associated. There was a comment on this in the chat. Data sets, code, materials can all in principle be made available and be defined as products listed on a CV, submitted to a funder, and so on. And we can, as at that stakeholder level, at the funder level, recognize those. At the institutional level, incentivize those. So, for example, in some of our member institutions, we have open research prizes, we have open research practices in our promotion criteria and increasingly in our hiring criteria, and we're trying to coordinate that across our universities. And then at the researcher level, you need to provide the training in that. So we've developed the Primer series, and we're developing some other training activity around open research practices to make it easier for people to engage with these things. So you need that coordinated action, and you need to not just target the early career researchers, because if their PIs, senior mentors, whoever, are not engaged with these issues as well, then they're going to bump up against that kind of cultural inertia that's created by people who are still working in the way that they were taught 20 or 30 years ago. So one of the things that we're doing with those grassroots agents for change, our local network leads, is thinking about ways in which we can create a community and upskill those researchers, not just in open research practices and other approaches to generating reproducible outputs, but also the skills they need to navigate that culture change at their local institution, you know, leadership skills and how to have difficult conversations with PIs and so on.
Interesting, thank you. And how, so training has come up time and again, and it's obviously a clear area, both actionable and achievable within a limited time frame. So you're proposing and espousing really training across along the entire career continuum. So basically, does this mean that every actor in the whole process, so infrastructure owners, institution, you know, the people who define the PhD curricula, etc., it needs to be in at every level. Everybody owns this. Is there an action that we as a sort of multi-dimensional community could take to try and really create some coherence in this and not leave it just to the random walk nature that we have right now?
I think making sure that all of the activity in this space is aware of the other activity in this space is a really key thing, because there's so much going on at the moment because it's such a hot topic. And if it's fragmented, it will end up achieving far less, because slightly different solutions will develop in a siloed way, and the impact of those solutions will be far less. So, from our point of view, what we want to see is growth in the UK network, but more importantly, growth of other national networks, so that we can have a supranational coordination of effort across all of those, recognizing that there are idiosyncrasies in a sort of fractal way. Every country is different, every university is different, every research group is different, every researcher is different. So there needs to be enough flexibility to allow researchers and groups and institutions and countries to adapt the broad principles. But these kinds of organizations, this organization and supranational organizations, I think, can just make sure that the very broad guiding principles are in place, and that there is dialogue across the different elements of that ecosystem.
Very nice, thank you. So that sounds like a role for organizations perhaps like Science Europe. Bonnie, maybe you could speak to that a little bit. How do you see organizations like yours facilitating this process of awareness raising and coordination?
I think my pre-speakers said already important things. It's I think no one owns the space and the solution how to really proceed on that. Science Europe, I think, as a multilateral, multi-country platform, is ideally that different countries and different funding organizations can exchange best practice and discuss about the lessons learned and about the different initiatives in the different countries, in order to understand, as I said before, which lever would be the most appropriate to introduce a change. I think what is important with all the debate is also that there will be, whatever rewards and incentives you would design, that you need a flexibility that each research discipline can find its ground in this endeavor. However, that there are some commonalities. Of course, open science is very elegant because it captures everything, and it has the capability also to capture the whole research cycle. However, I think it's important that funders with the research community and all the other stakeholders like S3 Forum and many others, at least in Europe, would agree what is actually the future. Because even if you would make an interesting list now on rewards and incentives, you need nevertheless to show the way, the future to researchers in early careers. You have to explain how you can make a career by opening up. Is it can you make a career by contributing, making preprints? Can you make a career by sharing a software? So not only you have to, at least in my view, you not only have to capture all different research outcomes or products, but you need also to potentially in the future diversify the professions. Somebody like a data steward, somebody who's really helping with research data management plan, and would need a career or have a vision on how he or she can make a living out of it. Somebody who is very good as a journalist or speaking to the public or citizens, involving citizens in co-design, would need to be recognized. So this, if you conceive it this, then even from the traditional the career as a traditional scientist would kind of change also. So that's why it's way more complicated than if you want to change research culture. So first step is, of course, to streamline open science and to think about how to make things open. But I personally, I'm thinking already a little bit beyond that. So yeah, so that's my take on it. And funders, perhaps, because I talk more like probably with my head as a head of research affairs, but funders can help and make guidelines and propose as a platform, but funders cannot enforce that. It has to go together with everybody in parallel. If not, it will not work. Thank you.
Clear. Thank you very much. Bonnie, nice long-term vision there. And I'm going to actually propose something that I'm hoping we're going to hear lots of. Yes, that's interesting. Yesterday, there was a participant from the European Commission who said who observed that what was being talked about in the presentations was very detailed about laboratory processes. But how can the field support the funder when in terms of when sculpting calls and helping actually give guidance on practical solutions about improving robustness through the funding process? And we said we'd bring it to today's discussion. In fact, IATRIS does this already quite a lot with funders, charities and public funders, on supporting in providing mentoring services to researchers who are busy designing studies and doing translational feasibility assessments of applied research, these kinds of things. I think we're in a point now where the momentum is such that we can bring in these cross-sectoral stakeholders, bring the research funding community, the infrastructure community, the research practitioner community, and look at practical ways to actually solve some of these issues. The enabling you were talking about, Anne-Marie, there's a lot of expertise to support that enabling now. So the question is, for instance, Bonnie, do you think your membership would be interested in actually convening a workshop really focused around what are practical things we can do as a community? What are the tools already available that can help improve the research practice, the research process, really across the different stakeholders?
Yeah, I mean, I insinuated that we will just start the reflections on the, we call it now the recognition system in research, but and the project is outlined for 2 years. But yes, but it will be very important to have different diverse workshops and engage with different stakeholders, potentially bilaterally for different research disciplines, different stakeholders, and then having something collectively where we engage together. So that's basically our plan, but it's not yet formalized, or we would like to do a bit of our homework internally, and then we would reach out to the communities.
Clear, thank you. And Charlotte, I think you mentioned you had one question from the field.
Yes, actually I had one question for Marcus, because you mentioned in your presentation that the network is really about sharing effective practices. So what criteria are applied to determine whether some practice is effective?
Well, this is why I showed that process of continuous improvement, because of course we don't necessarily know whether or not practices are effective. And of course, what seems like a good idea can have unintended consequences or simply not work. And to give an example of that, the badges system that we've seen at journals, well, first of all, the first analysis that showed that those incentivized or promoted an increase in data sharing, that was a pre-post analysis, and there's since been a randomized trial which was less positive about the impact of those badges. But more importantly, the mere act of depositing data on a platform like the Open Science Framework doesn't mean that they are necessarily accessible, interoperable, or reusable. If you put proprietary data up with no metadata, no data dictionary, that doesn't get you very far. So we need to be constantly evaluating this, and that's where Anne-Marie's mention of research on research comes in. We are developing a meta-research group in Bristol. Malcolm MacLeod in Edinburgh is doing this work for several years. There are many groups across Europe, particularly in Germany at the Quest Center and in the Netherlands, for example, but elsewhere as well, who are applying the scientific method to science itself, and we need to have that activity going on in the background. So you have, I think, two sides to the same coin: the sort of structural activity that we've been talking about, that I've been talking about, but then the research activity to then constantly evaluate the impact of that, bearing in mind that, as I said in my talk, the whole situation is dynamic, and what works now will not necessarily be what works in 20 years' time, because who knows what technology will exist, what the nature of team science will look like, and so on.
Thank you, Marcus. Looking at the time, I think we're going to do a Twitter tablet now with a wrap up from everybody. I'm going to ask you if you can think of the one most pressing thing we can and should be doing now to improve reproducibility and robustness of research results. What would that one thing be? I'm going to start on my screen clockwise. Andreas, you're the lucky winner of number one.
That's a good one. As we have heard, there's so many there's so many places where one that one could tweak. But I think we should start with training on research conduct, on scientific conduct, how to design experiments, who to contact, and so on. And I think, but this is a long-term thing. So if you, it's really hard to say. I think. I think what could be done by the funders immediately would be to implement guidelines as to what is expected from researchers in terms of research conduct, data management plan. Have a real prove a real understanding of the project that you want to do, and maybe much more in depth than what is in part needed at the moment. And then once that sinks in at the research side, I think they will ask for training about how to get better awareness of the research. And then of course open research or open science is always a topic, and I don't think we need to improve much more there. But I think this fragmentation is something we need to address, and hopefully we can do that.
Clear. Thank you. Kostas.
Yes. I want to take the opportunity to comment to what Bonnie said last, and to also question. There was a question by Massimiliano, and another one about EOSC. The question about EOSC was EOSC is too technical, doesn't do things. Why does it do things about open science? We're in changing the culture, which is what we have been discussing, and about for reforming research assessment. We need also the technical infrastructure for that. And so Massimiliano said the DOIs for data sets. Yes. How many of you of research institutions and funders, but funders, I think we do our part of the work there, demand have a uniform policy that every single data set that's produced is properly annotated, is having a DOI, and it has rich metadata that allow the data set to be, and same thing about software, and same thing about all other digital production. So it's a question to you. Sometimes I feel that we have very often, I have to be like Kennedy was, I think, that said, what can you do for us? And they said, no, you should ask what can you do for your country. The EOSC also will support all kinds of policies of open science. It is not just about open data, as I said in the beginning. For example, the assessment of scientists will require data. These data today are oligopolies of very few companies. Yeah, and the most institutions do not have their own ability to base their assessment without buying this data, having access to this data. This is the job of EOSC also, will be, or publication infrastructure. We need the technical underpinnings of a publication infrastructure for researchers to take ownership of their knowledge production. So, in short, the EOSC is a technical infrastructure, yes, but underpinning all our policy objectives. And if you think it does underpin some of them, please let us know, because that would be very useful information. A final point that I was thinking about earlier is about research infrastructures. You also do very often evaluation proposals, because it's competition, it's competitive to access the infrastructure. Do you take into account open science or reproducibility or other related criteria per the previous discussion? I would be curious to know. Thanks.
Yeah, thank you. Bjorn.
I think I would put much more emphasis on the technical aspect of the experiments, and maybe have some kind of technical review process, so that it's really the transparency of the experiment is there. It can be understood. So beside the scientific part, also put more emphasis, more focus on the technical aspects. I think that would be really helpful to create reproducible experiments.
Clear, thank you. Marcos, please go ahead.
I'll take this in a slightly different direction. I think we need to target institutions, universities. They embody the culture that we work within. They hold the keys to the incentives, the promotion criteria, the hiring criteria. They send the senior academics to sit on review boards. You very rarely see senior representatives from universities at these meetings. So we're having the conversation, but the people who can actually make that change to the culture very directly are not currently part of that conversation. That's why we have the institutional leads at the institutions that are part of our structure, so that they can hold the feet of the pro-vice chancellors for research or whatever to the fire. And universities will follow the money. So the funders can I think, do a lot to get the senior representatives from universities in the room to have the conversation and to convince them how important this is.
Clear. That's a very, very clear message, I think. Also, the concept of moral hazard and bringing responsibility and control into the same room, and the funder has obviously has the most power there in terms of how to get the right people to the room and to really look at this subject seriously. Thanks, very nice feedback. Anne-Marie, please.
Following on from Marcus, I think, one of the things we need to do is join up across the system and be super clear about what it is that we all care about in words almost of one syllable. And then as a funder, we've got responsibility to put our money where our mouth is and pay for the things that we think are important, whether that's doing meta-analysis, whether it's training, whether it's data management, whether it's, annotation or software. So it's be clear, pay for it, and then, there's an assurance mechanism.
Thank you very much. Volker, please go ahead.
Yeah, I think from our side, I was thinking also a little bit about what Marcus said. It's a lot about incentives. It's a lot about enforcing it. And obviously, based at a university here, it is quite important when you talk about funding of universities and publication points. And obviously, that's one of the criteria for funding, for example, in Norway, that publication points are important. And maybe that could be extended not just for scientific publications, but also for publicizing data and information on the other topics like reproducibility.
Clear. Thanks very much. Bonnie.
Yes, I agree that funders have the convening power to engage notably with institutions like university, as Marcus said. Perhaps, yes, what is important, and Anne-Marie said it, clear guidelines, being very clear about what's the expectation, but also support scientists to make it not more complicated, but make it more easy, so that they understand also that it's not making their life difficult, but supporting them. And perhaps for address to funders or to my members, it's I would say also be more bold, testing more, experiment with new methods, and seeking partnerships like in fora like here.
So the funder becomes the researcher, experimenting with new ways of doing things. I think that's a really lovely take-home message, and be a bit bold. If I may just bring in very briefly an anecdote. I was once in a room of ERANET funders. It was more than 30 funders in one of the ERANETs. We were trying to bring to them this concept of our community supporting with methodological expertise in projects that were about to be financed, that reached second stage. And the two pieces of feedback we got, one from a very large public funder in Europe, was we're not here for translating outcomes to society. We're here for cheaper research. This is literally what the person said. It was terrifying. And the chair of the meeting said, oh, we don't have a problem with quality. We have a methodologist on the review board. That was the sum total of the room of 30 funders. But this was 5 years ago, and I think it's wonderful to see. Hopefully those days are over now. And where we but the funder, we do sense a lot of fear of change within public funders particularly. And I think this momentum and large trusted funders like the Commission and Wellcome Trust doing these bold things, I think really will help the field develop these skills. So we look to you as our pioneers and guides, and help bring the other funders in that. And we'd really like to support that process in any way we can with workshops like this and in the future as well. Any final comments from the panel? Otherwise, I'll do a very fast summary. No? Okay, super. Well, this has been incredibly interesting, and we were a little bit afraid how we could get people to talk across from astronomy to social sciences to life sciences, but it's been wonderful. We see that the opportunities are clear. We won't say problems, we'll say the opportunities are clear and cross disciplinary. We look very much forward to, I think, taking this further. I don't see this as an end. This is definitely a beginning of something. I think the ERIC Forum being cross-domain is an opportunity for us to have discussions like this. We hope you will continue these discussions with us, because I think we have a lot to say and a lot we can do together very practically on a very practical level. So we're going to follow up with yourselves, the speakers, and any interested audience members. I think we should encapsulate some of the conclusions and calls to action that we've espoused today, put them down on paper, and see if we can put this into a journal and really get the world talking a little bit and talk about practical solutions. So if you'd be interested in that, we'd love to work with you on it. We'll come back to you after that. To the audience, some of the initiatives are very open and want to hear from you. The Equipped Consortium, I think the UK Reproducibility Network would love to hear from countries that might be interested in this. So do please make contact. If you need to get anybody, you don't have their emails, you can come to Anne, Charlotte, or myself. This has been very great. Thanks a lot. We do hope to follow up. And if you have interesting initiatives, let us know. We can disseminate those to others. All the best to you. Keep safe and healthy. And thank you again for all your contributions.